that would just stand, because obviously we can't just remember everything, or especially at the start of the course we can't remember. So just to put those basics in our mind, suppose this is our computer, and there's that let me just type the whole thing quickly. So this is your physical computer. Okay, so is that correct? Just kidding. So yeah, physical computer, and then there is that RAM. Yeah, I'll correct that. So, and then there is that hard disk, and then there is that processor, and then network card. Well, we say card or adapter as well. So what are these guys doing together? So, and it's always better to have a picture, when we're talking about some things. RAM, and that's computer, not Dodge RAM, right? So there you go. So that's RAM, and I'll just put that. When we go in depth with the types of RAM, then you will realize, oh wow, it's like extensive. But what does it really do? So that we should remember. So that's RAM, and okay, RAM is here. Then where's the hard disk? Okay, let's grab a hard disk as well. So there are two types actually: HDD, hard disk drive, and SSD, which is solid state drive, right? But hard disk drive computer. So how does it look like? It is this. Well, that's the inner side of the hard disk. In fact, that's even better, that we're seeing the platters there, which we will be discussing. And just like there was a gramophone, if you've saw or heard that before, that it used to have a needle, and there would be a very big disc moving, and like that, right? So it would be singing like that in old movies, right? I used to watch war movies. Okay, so here processor. Now we already saw all that because yesterday we saw that, but we're gonna go in depth. But what do they do? We have to be very clear about that, right? So you've already seen that. Now what I was telling you more, that latest processors have. Okay, can you tell me what is the difference you're seeing right now here between this and this? What is the difference you're seeing? So she's saying one of them does not have pins, other one has pins. Yesterday I told that older processors have pins and newer processors do not have pins, right? So that's very good, because the pins can be bent, right? So if they are slightly bent, that's it, your processor will not work. Oh, that's why that when they were saying hey. So so that's pins, right? And yeah, so well, I was thinking of passing on this processor to you guys to tell me which ones are bent, but that's pretty clear when you see that. I mean, it's like an extra thing. And so there are 4 pins that are bent. So this processor, if you can very delicately bend the pins, then you can make it work. Otherwise this cannot work now, right? So the thing is that this picture just shows you that this picture and this picture, right? This is without pins, so you just put it, works, right? Okay, so what I was talking about was now this is older processor. They do not come this way nowadays, right? But I was talking about what do they do, and that's a big picture, so I'll just make it smaller. So that is processor and network adapter. Okay, that would be easy, but when you see the picture, that is always better. So network adapter computer and images, and you would see a typical network adapter would look like this. Okay, need a bigger picture. There you go. So Copy image. Thank you very much. And so network adapter here. Okay, now the purpose of each and everything here. So there's data there, and what do you mean by data? So you have an operating system here in a computer, operating system, and then you have applications on top of that, applications, right? Those applications need to be powered on. So operating system has to be, the physical machine powers on, it starts the boot files. There are boot files inside boot files, right? So first, when I say boot files of an operating system, can you give me in plain English what does that mean? Boot files of an operating system mean, what does boot file do? What is boot? Start. Boot is not what we are wearing on our feet. So that and reboot the computer. That means reboot the computer. Boot means start, reboot, restart. So hey, boot the computer. Okay, power on. This means power on, right? So boot files, files that help the computer to power on. The operating system, the OS, help the OS or operating system to power on. Okay, so I was just telling you the starting process of a computer, and as soon as you power on the physical computer, what happens is the boot files start, they initiate the operating system, and the rest of the operating system also starts. But as soon as the software starts, this all software was living in hard disk drive, which is this hard disk drive. And when you start an operating system, the whole data, this is all data, these are files and folders, right? The whole data is living here. It starts loading up on this RAM. So if it is 2 GB RAM and this is Windows 8 or Windows 10, it would take really slow. It will take more time to start this computer. If it is 16 GB RAM, it is Windows 8 and 10, that would just start fast, right? Depends on the capacity of the RAM, that how much data it can load in those chipsets there, right? So you power on the computer, all data that was sleeping here in the hard disk, hey, wake up, early morning, come on, we need to work. So they all start getting loaded on that RAM. But how the message is going from the physical computer motherboard to the hard disk and to the RAM, this guy here, processor, is saying, hey guys, somebody powered on the computer. So since I'm the boss here, the processor, so hey, data from hard disk, yeah, you, the boot files, and the operating system, well, please, you need to start. So can you start just loading there? And they all say, yes, sir. And they all start loading there. So this guy here is the processor that is regulating everything. That is, the tasks are, or the requests are coming to the processor. It's executing those requests. The request is to power on the computer. The request is to boot or retrieve all the data of boot files and the operating system, load it on the memory, so the user can actually log into the operating system and use the operating system, right? So this is how the process is. The data lives here on the hard disk. The data for usage loads on the disk, on the RAM, or on the memory, but all this is being executed by this guy, the processor, right? And what is this guy doing? In fact, what is this device? Obviously, that's one remaining here. Network adapter. So you connect Ethernet cable to the network adapter, and you connect to network and internet connection, right? Network and internet connection. So now, anyone, in fact, hey, let's play a game now, right? So everyone will tell in least amount of words what's going on the board. Ha, gotcha there. So let's start. What is happening here? Yes, ma'am.
The computer's turning on to the hard disk and storing all information, getting it to the RAM to load, and the processor will tell the RAM what to do, and the network adapter will connect it to internet.
Wow. Okay, cool. Yes, sir.
So the processor is, it takes the data from the hard disk, it loads it onto the RAM, transfers to the RAM, and then loads it there. And then the Ethernet cable establishes a internet connection. The network adapter connected to an Ethernet cable establishes a network connection.
Cool. That was simple. Yes, sir.
So, power on the computer. The hard disk stores the information. Loads on the RAM, which is regulated by the processor.
Well, this would be the first then. Processor is receiving all the commands. Then the after power on, in fact this is the second one. Then this is, the processor says, hey everyone, get up, early morning, and it starts loading on the RAM. Fourth. So one, power on. Second, processor, yes sir, what do you want me to do? Oh, all the data there, okay, hey, wake up everyone, load it on the computer, and the user wants to use it. Okay, once there's there, then you connect to the network, you connect to the internet, and you start watching YouTube. Hello, testing 1, 2, 3. Oh, yeah, you. Okay, yes sir.
I don't know. I was busy internet.
With you were.
I was texting.
So why were you texting?
And,
You were in the class, right?
on my bed.
You're bad. Okay. So there will be 2 classes now. One is,
From now on.
yeah. So let me explain that, and I'll still push you to do that, right? So I'll explain now, and you will explain me now, right? Are you ready for that, or do you want me to skip this?
I will be ready.
Ah, confidence. That's what I want, man. So you power on the computer, and then the processor is told to access all these files which are living here to load on the memory here. So processor tells the files which are living here to load in the memory here. And once they are loaded, then you log in, and then the network card lets you connect to the network and internet. Yes sir, can you repeat that?
Sure. The processor send it the information
To the oh yeah, this guy is this.
hard disk.
Yes.
And then it process the
Yeah, the whole data is loaded on the RAM.
and then
RAM.
yeah, it loading the RAM.
Yeah.
And then it send it the
Hmm.
OS.
Okay.
Yeah. And
Somebody needs hard work. So please do watch the video. I will ask you in next class as well. Woohoo! Yes, that's exciting, right? Good. So please, what I want is your attention, right? So at the end of the class, if whoever is not paying attention, I take the cell phone, I take it home, and I format it, and it's mine from now on. I'm just kidding. Okay, so I wish that would be good. Okay, anyway, so just kidding. But please, this is very important for us to understand, right? That's what I meant to do. So anyway, if we understand that now, so what is the difference between RAM and hard disk? Now it should be quick.
RAM loads from what the hard disk has stored. It gets transferred to the RAM, and the RAM loads it.
So what does hard disk do?
The hard disk stores memory, and the RAM
Stores what?
stores memory. The hard disk stores files.
That's it. Storage, right? So hard disk just stores files, right? And processor. It receives commands and execute tasks. Processor So this is just how these four critical components are working. If we have this mind, okay, hard disk stores, RAM loads the data temporarily. As soon as you power off the computer, what happens now? Power on, I told you. What happens? Can you tell me what would happen when it powers off? Where does the data go? From where data goes to where? If
hard disk.
it was loaded here, it was. Oh, where's my mouse? Yeah. Oh, seriously? Oh yeah, here it is. So it was loaded here, it was working here all the time. As soon as you power or shut down the computer, what happens? It goes back to where it came from. Where? So there you go. So it was loaded in the RAM. As soon as you shut down the computer, it unloads from RAM and goes back to the storage where it was there, right? Now we're talking about, okay, on RAM it works. Then later you will list here some portion of the hard disk is used as RAM, and that is, I'm just telling you now, not to be confused later, that's called page file. Suppose the RAM is saying, whoa, that's too much data, come on, any help here please? So what happens is that some of the area of the hard disk is used as RAM as well, and that in Windows language is called page file. In Linux it is called swap file. So this is just, you want to use some portion of the hard disk as RAM, as memory. So it loads there as well temporarily as a memory, and it lets you still do that, use the applications. But it uses some portion of the hard disk as well. Later we're gonna find that out as well. Just I'm adding that later. If you see, no, it's just memory that it loads. No, sometimes it's not sometimes. Windows, when you install Windows operating system or Linux, it does that. It creates a page file as well in case memory runs out of space there for loading applications. Suppose you're double clicking Word, Excel, PowerPoint, and then Google Chrome, Internet Explorer, and some other applications as well, and one game as well. Wow. So it really says at certain time that, hey, that's it, okay, that's it, I can't take any more. So either we get an error. So first of all, if it can't take it anymore, it's gonna offload some of this area to, some of the data to this hard disk portion called page file in Windows, swap file in Linux. If depends on which operating system is installed on the physical machine, right? But the main thing, you should have an idea about, okay, when the computer powers on, it's going there. When powers off, RAM unloads and it goes back, right? So any questions till now? Time up. Okay, let's go ahead. So but it's not time up, you can ask anytime, right? So it's not time up. And so here now I have some slides here from Cybex. I don't have all slides from Cybex. It had some good information about that. I had to collect data from different sources there in terms of which was like more to the point, more you could understand better. Otherwise some straightforward data in the actual official book is kind of more confusing than than you may understand. So what we are talking about is first the system board, and that's what we talked about last time as well in the class. So system board here. So I'll be throwing questions at you anytime, so it's kind of be alert. Okay, so first of all, this is called motherboard. Is the spine of the computer. It connects all the components together, and we saw that already. You handled this already, and you will see that in some motherboards the architecture will be different, and that architecture is called something. So we're going to talk about those motherboards, and all of a sudden I'm going to throw a question at you, and let's see if those who are on cell phone can also answer that. I'm not talking about you. Okay. So just to be attentive, and I'll be putting some quiz questions to you as well. So I'll give you a quiz later. So motherboard form factors. Well, first of all, what is a form factor? Ever heard of that word before? No. Architecture. So they want to say it just in a different way. So form factor just means the architecture, and you can see 5 types of motherboards. First of all, uh, what what do you think? Where this? Okay, ADX, big motherboard, right? Smaller, micro ATX, and then we're gonna talk about ATX and ITX as well. Then mini ATX, ITX, and then nano ITX and pico ITX. What is ITX? We're gonna be talking in detail now, but we understand this is a big one. Okay, maybe you have a big case there, so you would see that okay, there are so many adapter slots here. There is what do we put here? RAM, right? And so and what do we put here? This is like from space you take a, or from Google Maps you take a picture of something. Okay, anyway, so the hard disk here, right? No, processor. Hard disk or
It's
processor? Hard disk? Professor, right? Processor. So what it, this is big. This is maybe this size, right? This here. What about these guys? In which kind of devices would you have such small motherboards? Which kind of devices? Can you guess? Laptop, smaller laptops, or tablets. Exactly, tablets, right? So, and it goes even smaller and smaller, and you can see that every device needs a RAM, every device needs a processor, every device needs a storage, every device needs a network. Four things, right? Four major things. Every device, no matter how small, how big, if that's the functionality you want to take from that. So there are different types of form factors. First of all, ADX, micro ADX, and IDX. If we go a little ahead, further ahead, so system board components are chipsets, expansion slots, and buses. So when we say expansion slots, these are the expansion slots. Maybe you already have a connection here, VGA connection, which is video graphics adapter, but you can just put a display adapter here as well, right? If you want some extra work, maybe yesterday we talked about that as well, right? That if you want to play a game or Bitcoin mining you want to do, and you need some really good power there, so you can do that too here. So if we have this expansion slots and buses, then memory slots and external cache. Anyone knows what's the meaning of this? Cache or cache? To say it. Sorry? It what? External hard drive. Okay, you're saying that. Anyone else? Ever heard of cache before? This one? Data. Okay, anyone else? Ever heard of cache? Hey, in Cisco.
Cache is it's data that's been stored.
So data stored locally. That is called cache. Data stored locally. Data but stored locally. So if you have a shared folder, you're sharing some files with a computer, and you want to use that offline. So as soon as you click that feature, I want this file offline over the network, it is okay. But whenever network is not available, I'm disconnected from the network, I want this offline available. Offline means it will cache those files as well. They will be available over the network, but they will be locally stored on your computer as well. A copy of those files will be locally stored on a computer. So whenever you say that, oh, this is a cache disk, oh, okay, so this means that all data will be locally stored on this disk. That's why it's called a cache disk, right? So the word cache in IT means, or cache, some would say that is locally storing data, right? Okay, so memory slots, and when we say memory slots, so obviously we already know that this is memory slot here, this is memory slot here, this is memory slot here, and it goes really blur here, so it could be this one, and here it could be this one. But anyway, if we go ahead, CPU and processor sockets, so processor socket would be, this is a socket, right? This is a socket. And here, where's the socket here? So this is a socket. There are two sockets here. So multi-sockets there. And if we go for a picture of, more than one socket, ever saw motherboard with, so 4-socket motherboard, 4 socket motherboard Xeon. Okay, 4 CPU socket actually it should be. But when we say 4-socket, are there actually 4 sockets there? So you can see, wow, that's heavy. I mean, like some devices have this kind of architecture where there are 4 processors there. So if I just put that as well, that's not very clear. But this is older model, and I'll just try to put that a little bigger. Really? So 1 socket, 2nd socket, 3rd socket, 4 physical processors are available here. That would be, you can imagine the speed there that it will offer. So it looks like, any of those 4 sockets here. And this will be a big motherboard. And normally there are servers. There are big machines. So and when I say servers, always just have a picture of that IBM server or HP server or Dell server. When we say server, these are big machines, right? So these are really big machines here that would have this kind of motherboard or this kind of motherboard inside. 4 sockets here, lot of expansion slots here, and a lot of memory slots. So you can also see here how many memory slots are there. Wow, it can go up to 200 GB memory. Normally our laptops this laptop can go up to 32 GB memory, and that is expensive, right? This laptop is expensive because 32 GB memory it can support. If your laptop can support 16 GB memory, so it has 2 slots. My laptop also has 4 slots here and 888 GB, right? But this is how, if you go for much bigger servers here, then you can see and you can imagine. I have a desktop at home that supports up to 200 GB memory. So it still has 6 slots, 6 memory slots. So these are actually 12. It has just 6, but each slot supports like even 40 GB stick, memory stick there. So when I say memory stick, I mean what? This looks like a stick, right? So it's a memory stick. They also call it memory stick. So what I'm trying to show here is by pictures you should have an idea what are we talking about when we are saying some words here. So if it's CPU and processor sockets, we can see that there is single socket motherboard, which is this single socket, and then there are 4 socket motherboards that you just saw the picture of. So that can also have and it looks like the way you saw that, right? Am I recording that? Yeah. So power connectors, obviously you will have a lot of power connectors here. So by color, which is the power connector here? Orange and white?
Red.
Orange and red. Power connector. When I say power connector, from there, the motherboard is receiving power from this PC. If the power is disconnected, no power here.
Yellow, sorry.
Which one?
Yellow.
Yellow?
Yeah.
Okay. There's a component here that is colored yellow, and you're saying that it is power connector for the motherboard. The motherboard receives all the power from outside through that connector. I'm talking about that connector, right? So you're saying some component here is yellow that is receiving all the power from outside, right? So anyone else agrees or disagrees to that? Where is the power connector here that is receiving all the power from outside, and because of that power, motherboard is really having electricity? Oh, good. You're trying to compare the shape, huh?
Yeah, there's the black one. So to the right.
Okay. Hey, you did some investigation. After that, what you're saying? The black one. Okay. So yellow one, black one. Yes, sir. Which color is the power component is the power connector? It has a specific color. I'll know if you tell me. That color is very clear here. Power connector, that is the central power coming to this motherboard right now.
Yeah, it's the top. Is it
Or
yellow?
is it beige or white?
It looked yellow.
Okay, because of that light. Seriously. Okay, now there's no light. What color is beige or white? You're saying beige or white? You're saying it's always good to.
Yeah, it's the white one.
Which one? You have to say it. I want some confidence there.
The blue.
The blue one.
Yeah.
Okay. So blue one is this, right? This is what you're saying. So yes, this is the power. Hey, what else was white? Did you refer to these guys? It was this all the time. This, this. So this is the power. Why? Because this guy here. Are you able to see that? Right? This fits here. That's it. Right? This is the main power coming to the main board, motherboard or main board. Right? So, oh seriously? Okay. What will we do now is, please, you will be connecting this and disconnecting this from here. You will be connecting this to this motherboard and disconnecting. You will be connecting to this motherboard and disconnecting, and you will be connecting to this motherboard. So if you have connected to this motherboard, you will be connecting to the other motherboard, right? So I want you to feel how to connect the power supply to the motherboard, and it's a little tricky. I want you to figure out. It's very simple. I just did it in front of you. Connect, disconnect, right? But when you do that, you will find it a little tricky. Why? So can you please connect the power of the power supply to the motherboard? Fixed. Yeah. Is it fixed? No. Give it a push. Okay, good. Okay, good. Hey, you've done that before. That's not fair. Just kidding. The other motherboard. Yeah, this one. So there's some power required to connect the power. Thank you, sir. Yeah, the other motherboard. So when you do it, after that, it's like, oh, okay, now I have an idea where to put that. And when you do it, you don't forget that easy. When you listen to it, after 10 minutes, gone. Now you won't forget that. Oh, okay, this is how I connected the main power from the power supply to the motherboard. Yes, sir. Thank you, sir. Yes, sir. Power connectors. That was just one power connector that I wanted you to connect. There are many here. This is the main power supply. If that is disconnected, the whole motherboard, it goes off. No electricity, right? Yeah. So this is, an unused, this is garbage, right? But when it's a live computer, you have to be very careful. So if the motherboard is connected here and we put it there and then we push it, right? And one time, one of my friend, he was pushing it hard and he forgot to power off the motherboard. So as soon as he pushed it inside, the button was still, some older computers was connected. So it just turned on right away, and it just blew up. That blew up means just that it was short circuit and the motherboard was all capiche gone. So there was just power already connected there. Normally when you do that, obviously make sure that any kind of power cord is not connected already and the button is not pushed already. It used to be like that. The button push is it would be either permanently pushed or you can just turn it off. So alright guys, now we understand that when we talk about power connectors, this is the main power, but there are many other power connectors. Because we did not talk about that last time, there are many other power connectors here as well. So understand that the power cables would look like this, right? in an older computer. In a newer computer, they would look like actually that data cable that we were, yeah. So the power cable in some newer computers are nearly looking like that, but normally they would be always looking like this. Even in newer computers, some of the newer models have actually a bit confusing, color for the power cable. But this is how power cables. Now, this is also a power cable. This for the motherboard, so this has to go somewhere as well, right? Any idea which device would it connect to? It would connect to a hard disk, right? And it's a SATA connection because we haven't talked about the hard disk. But I'm telling you some of the things now. When we talk about it later, you would be recognizing it from the past. Okay, so motherboard has power connectors, onboard disk drive connectors. This is what I just mentioned. Onboard disk drive connectors. One is this, and one is this. Can you tell me what is the job of the two? What does this do? What does this do? We just talked about it.
That's for the hard disk.
They are both for the hard disk.
To power supply.
To do what?
With the hard disk does storage.
Okay, so this one does what?
That one supplies the power.
That will send the power, that will power on the hard disk drive, and this would
Transfers the data to.
so data transfer, this cable, power, this cable. Hard disk needs both. You have to connect this, and you have to connect this as well, right? So if one of them is not connected, obviously there's no use of that hard disk, right? So power cable and data cable. So they're talking about onboard disk drive connectors. These two are onboard disk drive connectors, right? Keyboard connectors. Now, yesterday I told you which ones are keyboard connectors here for the older motherboard. The purple and green. So the purple and this one. But nowadays it's all USB, right? USB or Bluetooth. Excuse me, I think it's a frog. Wow. There was a and the whole thing was like moving. That was scary. So you're like, okay, let me just sit. Okay, so keyboard connectors, we understand that integrated peripheral ports and headers. So peripheral ports and headers, really? Peripheral ports, what do you see here? Oh, that was the easiest thing. I mean, I just gave you the answer right away. I should have done this way, and then I would have guessed there. You would have guessed there. But peripheral ports, as soon as I showed you this, those are all the ports here. Peripheral ports for USB, for sound, for what else you see here? For sound, I see a port. There's a port for VGA, which is display. Which one is that?
Video graphics adapter.
Which what color is that? Okay, good. You remember that. So USB colored up. There's another one for display, and then there's a parallel port that is a long one, purple one, and that used to be for the printers, old printers, but now it's again everything is wireless. So then comes the BIOS. Now you may or may not have heard that before. Basic input output system. BIOS, basic input output system, BIOS or firmware. BIOS is the brain of the computer. You configure the computer basic settings with the BIOS, right? But we're going to go inside the BIOS and we're going to check that. That's why I need you guys to be there on the computer room, so we could actually see a BIOS as well. That my laptop, I'll keep it away from that experiment. But I'll show you. Oh, yeah, I can show you. So, well, it'll take time to start, but I'll show you the. When I say BIOS, you should have some picture in mind that, oh, okay, that's what he means by BIOS. I'll just start up Windows 8 or 10. In fact, as soon as I start, I will be able to see that. Oh, this one. Okay. If I yeah, let me just. This is virtual environment, but the BIOS they've created is exactly the same as in physical computer. In a physical computer, you press Del or setup Del or F1 to go to the BIOS. But let me just show you first what I mean by BIOS, and that is power on to firmware. Yeah. So in a this is a first of all what I've started is many of us may know that, and many of us may not know that. But VMware Workstation, ever heard of that before? VMware Workstation. So that's the training virtualization software. Inside this software, when you double click, this is kind of a revolutionary software way back. These are virtual machines here. This is virtual machine. This is a physical machine. Exactly the same stuff is done in a virtual machine. So if I click that here and I resume this virtual machine or power on this virtual machine, so this software loads the virtual machine that works and acts exactly like a physical machine. The only difference is it is made up of software. This is made up of hardware, right? So when this virtual machine starts, it's going to be Microsoft Windows inside. There will be virtual hardware inside. Virtual hardware means it is hardware, but it's virtual, which means virtual disk, virtual memory, virtual processor, virtual network card. Everything that is physical you're seeing inside this environment of VMware Workstation, it is all virtual. So that is virtual hardware, right? And this is something that you will face a lot. This is like after A+, maybe you will never face that. Or maybe the boss says in the company, hey, you've done A+, can you just fix that PC, just internet connection? With the hardware, it's not going to be a lot that we will be doing there. 3102 templates, where is it? Okay. So the thing is that it works like a Windows. It is a virtual machine. I start that. Now inside Windows works like that. There's Internet Explorer here, right? And and there's a virtual network card here. And that virtual network card, if you've ever given an IP in a network card, so you can give here an IP here. So this is all virtual machine installed in a VMware Workstation. We will be using that to actually do our tasks there. So I'm just gonna go for suspension of machine startup. Guess. Oh, okay. What is this? Suspend. Okay. Yeah. so yeah, everything okay, but yeah. So it's like, oh, okay. So you. It's basketball or baseball you play? What? Basketball. Okay. So after that, you're like, and then like, so that's new for me, because the whole screen is moving now. Like, whoa, what happened? So yeah, this table is actually, this is to be claimed. Now this table here, if you want to lean on that, that would be not moving, but this table will move as soon as you touch it. Okay, so it's okay. I mean, please do go ahead, but it's just that just at once the whole screen moves. So next time I'll understand. Okay, you're trying to move. So Ethernet, and here I'll just put it back to suspend it. So guys, I'm trying to tell you here, power on firmware. I'm just going to go to the BIOS now, and it's going to, yeah, this is, so just to show you that BIOS is the brain of the computer, it is going to tell you there's a primary hard disk, there's a primary slave, there's a secondary master, there's a secondary slave. Now you can have in a desktop 4 maximum hard disks. In a server computer you can have 20, 30, 40 hard disks. In a desktop you can have only 4 maximum. So there's a primary master, there's a primary slave, there's a secondary master, secondary slave. So with one cable, why is it called primary master and primary slave? So with one cable there are two connections here, this connection and the other one, this connection, right? So with one cable the disk can be connected as well, and so the master disk and the slave disk can be connected to the same connection, but they are totally independent disks. They are just called master slave because they are connected through one cable there, right? And then there's a secondary master and secondary slave there, so that would be also the third and fourth disk there. So but the main thing is BIOS looks like this. Advanced, if I go, there are security settings there, there is memory settings there. If you change anything here, that could be devastating for the whole computer as well, if you change something wrong here. So there's a security here, you can just put the password on the BIOS as well, and nobody should be messing up with the computer's BIOS, and you can break the password of the BIOS as well. There is boot sequence. Ever heard of boot sequence before, or start sequence? What does that mean? Ever heard of boot sequence or start sequence? So why do we use that? Okay, so which device, when you power on the computer, what is the sequence in which the computer should check that where is the operating system? Oh, let me check that removable devices. The top one is showing removable devices. So let me check that if there's a removable device. What is a removable device? USB. You connect to USB and it checks that is there an operating system in the USB. But that's a small stake. I mean, there can be an operating system, but we don't have. Then there is that hard drive. It's going to check first this, then it's going to check the hard drive, and it will say, oh, I found an operating system here. Okay, let's just start or boot from there. Or if it finds bootable CD-ROM, then it can just start installation of operating system there. And network boot means it will try to search from network card. There's a specific chip called PXE chip, PXE, which is pre-boot execution environment. So what happens is that if it doesn't find an operating system in all these devices, it will go to the network, it will ask the network card, hey network card, can you just search for a local DHCP server? Okay, I'm saying so many terms here. Ever heard of DHCP server before? Never. So we are using DHCP every day at home, in college, in Tim Horton or McDonald's where you go. So if I say that, is that true or false? We are using DHCP every day, everywhere. Why? DHCP's only task is to give. I'm looking at just one guy now. Oh, okay. DHCP only gives what? IP. So your cell phone is getting internet. Why? You get an IP address. It is an address over the network for a device, right? So when you go to Tim Horton, oh, let me check my internet. So maybe you don't have a data plan, so you will connect to a Wi-Fi. As soon as you connect to Tim Horton's Wi-Fi, what will happen? The DHCP there will automatically give you an IP. Oh, you connected to my network. I am DHCP, Dynamic Host Configuration Protocol. Let me send you an IP right now, because you connected to my network. As soon as the device connects to a network, it requests for an IP. So you take a laptop to any restaurant and they have a Wi-Fi. As soon as you turn on the laptop, it will automatically look for a DHCP. Hey, is there any DHCP that can give me an IP so I can connect to internet right now? So wherever you have internet connection, because your device is connecting to a DHCP, Dynamic Host Configuration Protocol, right? So, and that's what, so as soon as you go home, you're connected to internet. You're here, you're connected to internet. Why? You get an IP right away. As soon as you connect to that SSID. What is your SSID here? Okay, that is SSID. As soon as you get the SSID, you type there or you select that, you get an IP from DHCP. So BIOS, you have so much configurations here in a computer, and this is the brain of the computer. For some reason, it is called that. If you make any changes there that you don't know, that it can harm the computer as well. So we have to understand what is BIOS and the next version. So BIOS is kind of a grandpa, and UEFI is a newer version of the brain of computer, right? UEFI, and we're going to be talking about that as well. What is UEFI? How does it work? And why is it called the brain of the computer? You can configure all the hardware. Oh, I don't want any disk to be detected here. This is very dangerous, right? So you can just come here, primary master, secondary master, start disabling these. Then when you start the computer, it will not detect any hard disk. Dangerous, right? So it will not detect any network card. You can configure here. So you can do basic hardware configurations that can make or break this computer by BIOS, right? So when we talk, are we talking about BIOS? Because that's in A+. They want you to know what is BIOS, firmware is the software. We were seeing that interface here. So obviously the firmware, when we talk about, hey, let's change the firmware of this computer's BIOS. Okay, first of all, I remember to have suspended it. Oh, it's suspended. Okay. Oh, I started. Yeah, this is. So, guys, this what you're seeing here is BIOS, but this is obviously a software, right? It's a software inside your computer. So, in the server or in the physical desktop, if the boss says, "Hey, can you go to the BIOS and change the boot sequence?" That is one of the common requests. Can you go to the BIOS and change the boot sequence? I want to start this machine not from a hard disk, but I want to start this machine from, this is a hard drive here. So I want to start my machine from CD-ROM. Do you know that on what occasions do you start your machine from a CD-ROM? When do you need to start from CD-ROM instead of hard drive? When you're installing a new operating system, at that time you go to the BIOS, you change the boot sequence, and changing the boot sequence just means that if hard drive was on the top, I could just put shift plus here or just plus sign, and I say that no, computer, when you power on, just detect the CD-ROM and check that if there's a Windows 8 in the CD-ROM right now. I just put the CD-ROM up there right now, right? So this would be the case. I'm just putting it down now, minus. Okay, hard drive is up. If I just up arrow that and plus, now it will just detect the hard drive first, and it will find an operating system inside, Windows 8, Windows 10, and it will start, right? So BIOS really is important, and you have to check that. We'll be logging into it. We're gonna detect that those things there when you are moved to the other class, because we have Vmware Workstation software in every computer. So you will be installing Windows 10 there, and that will be an exercise for how to install an operating system, what are the precautions to take, and also to use the BIOS, how to use the BIOS, right? So if we go further ahead, we wanted to know peripherals. Peripherals are on the motherboard, keyboard, mouse, sound, and then onboard disk drive connectors. I showed you two connectors. One is power connector, one is data connector. Then there's Cmos battery. So here, you know the name Cmos battery, the name battery. What component here resembles that? Can you give some location, some color of that? What looks like a Cmos battery to you? Besides the heat. Oh, okay. So do you agree? Do you disagree to that? She's saying beside the heat sink is a component that looks like a battery. Battery would be like watch battery. Well, watches used to be in old time. So CMOS battery is exactly as you said, this thing here, right? CMOS battery. This is a battery shape, and this is where all the BIOS information is saved. Now, at home, I didn't want my kid to be playing games while I'm gone and during the summer vacation. So I would just put a password. I once put the password on the computer itself. So you can do that too. The computer starts and there will be a password. You cannot just, he didn't know the password. So he went to YouTube from another device, from his mom's computer, and from his mom's actually cell phone. So he saw that how to go to the motherboard, open the computer, and then take out this battery As soon as you take out the battery and put it back and power on the computer, the password is broken. So anything you configured in the BIOS is saved in the battery. As soon as you take out the power off the computer, take out the battery, put on the battery back, power on the computer. Everything is factory reset. It reset to factory settings. So he saw it in the YouTube, 10-year-old, and he broke that. And that was not all. Then my local administrator password he broke as well. And I said, seriously, are you kidding me? Why don't you use this talent to some good? Okay, so this also happened to when I was a system administrator back home in a university. And there was one server, and its storage. There were 32 hard disks there. All hard disks were connected, and that knowledge of connection was in the battery. That battery got expired after what, 10 years? So it stopped working. So the information, oh, there are 32 disks connected to each other, information that was lost. As soon as this was lost, all the data on the hard disk was lost as well. So just one battery caused such a huge level of disaster, and we had to change that battery, right? As soon as I put the new battery, now it's gonna start from initial settings, but we had to restore from backup all the data, right? So when we talk about battery, there's a task related to that. What is the task? Take out the battery, put it back in, right? So when we are disassembling the whole computer and then assembling the whole computer at the end of this course, and it better work as well after that, so you'll be disassembling pretty much everything. And this is the troubleshooting that do come with older computers, and you might face those computers in any company when you join, and companies would not let go of any computers. They would say, hey, there's a problem there. In resume you said A+. Okay, there's a problem I heard, and I talked to my vendor. They said, can anyone in your company take out a battery and put it back? So obviously that is you, because A+, you did A+, right? So some of my friends were given very unique situations where they were not signed up for. They were system administrators just handling big servers, and all of a sudden there's a computer CEO, hey, fix it. So if you were not able to do that, then the CEO would be staring at you. Really? You're kidding me? You're handling my expensive servers there and big network, and you cannot handle a computer? So that stare was really not that good. So I'm going to be giving this computer. Now this is your handiwork. This is your, how do you figure out to take it out, and how do you then put it back? So you guys, so this is, you will be taking out that battery, and this is what? Cmos battery. And once you're done, you can give her, and once you're done, you can give it, right? Take out the battery, show me, and then put it back. Or first you can see, you can do that, right, first. Let her do that first, and then you can see, right? And you can even, so yes, there is that figuring out to do, but you can see there's something to press there. There's a small thing to press there. And if you press it harder, or if you want to use something sharp, as a tool. Okay, so you got it, and you put it back. That was too fast. Fast and furious. Yeah. Thank you, ma'am. Okay. Yes, sir. And you can also just throw it on the wall. Don't do that.
So it's just like a regular varnish. Regular battery.
Yes, just like a regular battery. But this is saving the brain of the computer.
So you said that when this was it messed up, and then what happened was it removed all the files from the hard disk?
No, that was on the server side. That happened. In the desktop, normally you don't. If you're an advanced user, you would go to BIOS and you will keep boot sequence changes. You will go for security area, and you would just try to make some changes there. So those changes you really need for the computer to properly work, or to have some advanced features enabled in the BIOS. So if somebody takes out the battery, those are all gone. So normally gamers do that, and those who are really into fixing computers, and especially to use some advanced features of the computer, security features of the BIOS. So we have to just be more knowledgeable about BIOS. After that, we need to protect this battery. So, or just remember what you did.
But from the server side, this was corrupted.
Sir,
This got corrupted, and then all the files were lost.
in the server, yes. All the
How did that happen? Because you said that only files from the BIOS could be stored.
So this battery had the knowledge of 32 disks connected to each other.
And as well as the
So
BIOS.
it was telling the disk, hey, you're connected to this disk, you're connected to this disk, you're connected to this disk. That knowledge of connection was keeping the disk together, and some of the data was in one disk, some of the data was on another disk. It was all spread across 32 disks. So when the knowledge of that we are no longer connected, the disk didn't know they are connected, so the data was lost as well because of that. And that knowledge was actually in the battery. And we discovered it then at that time that how important this battery was. When we lost everything, learned the hard way. Oh, done? Cool. But taking out and putting it back was not that big deal. It's just that when we do that with some kind of background here, we understand that okay, this is so important. And we took out that battery, but it is the Cmos battery that has all the knowledge of the brain of the computer, and sometimes it totally depends on if you've Cmos is for computer, and then when it's abbreviation, normally I go and Google it, right? So I'm very bad in abbreviations. But Cmos does what? That's what I'm good at. Yeah, abbreviation is like I always go for the purpose. But when I'm coming there, so I will just tell you what is the abbreviation of that as well, right? So what the purpose is that it saves all the information of that brain, right? But now since you asked, I always try to answer at that time. And you will see in many other things that I put especially that abbreviation, because if it comes there, I have to then search. So, but let me just put that there. Cmos battery. So
where do you back up the data on the CMOS so that it doesn't get lost in the battery?
so that was for the server side only. Here, here it will set it to the factory defaults. When you purchase the computer first time, it has nothing set up there. That's the basics. But then you configure the BIOS to advanced features there. There is a virtualization feature that you have to configure yourself. So when this battery is lost, and this normally doesn't happen, majority of the millions of people will not know who are using computers that, oh, there's a battery there. I never use that, because you never had to. You never had to face that ever. So it works 10 years, 20 years good. So that's why nobody knows. But if somebody knows what to do with that, then it's a very nice tool to really annoy somebody. So if there was an advanced gamer guy kind of person, and he really went to the BIOS, oh, let me factory reset it for you. Gone. Reset it again. Ha. Okay. So anyway, but CMOS, why does we remove? Yeah, it's all about, give me that abbreviation. Well, yeah. As my motherboards, real-time clock. Okay. CMOS abbreviation. Let me just go for that, and let's clarify that. When there's a question, it has to be clarified. Complementary metal oxide semiconductor. That's why I didn't know that, right? No, but normally abbreviation, many of them I do remember, but some of them I'm like always Googling it in front of the students, so which is okay. So complementary metal oxide semiconductor. So it comes down to, what does it do? So I always go straight to, what does it do? So. But it's good to know that as well. In interview,
sometimes the abbreviation can tell you what it does.
exactly. Sometimes it is. It is like Martian language. So complementary metal oxide. So anyway, but the thing is that we will be, personal computers also contain a small amount of battery-powered CMOS memory to hold the date, time, and system setup parameters. That's what we were talking about just now. System setup parameters, right? So that's what I do, and we just powered off this motherboard. I mean, like we put it back to factory default, the what you did just now, right? But now we understand the purpose of BIOS. We understand the purpose of CMOS battery, right? That BIOS, whatever you configured there is saved because of this battery. You take it out, it is gone, right? So some of the main things should be understood by, you know, some of let's relate it to some practical as well, so we could just remember it. And then front panel connectors, that is like you know, the front panel here. So that would be this guy here. Front panel connectors are whatever's in the front panel. So what connectors do you see there? USB for what? Oh, what connectors is that? USB for USB keyboard, anything USB, external drive. What is the other connectors you see? Huh? Sorry? Uh-huh. So there is just mic and speakers, or actually headsets, exactly. So front panel connectors are these. How do you connect them in the back? Normally it's in the manual that tells you which cable goes to where. So, but front panel connectors are these. So obviously back panel connectors would be the other side of the connectors, right? Where there are more connectors there. So chipsets. Well, we're going to talk about in detail now, but obviously if I ask you about what is the chipset here, where exactly is a chipset that you can look at? There are multiple chipsets here. Where exactly on the motherboard can you look at beside what a chipset?
The processor is a chipset.
Okay, that's a big one, exactly. Or any smaller ones? So, well, maybe that's a hard one because, oh, that very small thing is a chipset, right? Chipset. So it is performing some functions. We would only know that by watching the manual of this motherboard, which is a big one normally. It's a booklet. You keep. Otherwise, we go online, and normally when you, even if you're really into hardware, this is not our concern. Chipset is there, okay, it's doing some tasks, who cares? But yeah, our concern is what components, extra components we are adding here, what kind of RAM we are adding there, what kind of hard disk drive, power cable we're connecting there, what kind of SATA connections we are adding there, what kind of processor we are adding there. That's whatever we are adding, whatever is built into it. Once we read it after that, it's okay. It's not that big deal. It's doing its task. It's normally chipsets are helping processors do its task. They're extra helpers, right? So understanding the bus. Now there are many routes in Toronto where TTC bus go. Okay, no, it's not that bus. So what is bus in a motherboard? The lines. So are we able to see very small lines there in this motherboard and this motherboard? There are so many lines created there, right? So you notice that. Why are those lines there? Any guess? We're going to be talking about that, but why? They talk to each other. So processor is given a command, hey processor, I have just turned on a song there. So the processor tells the sound card as well, there's a file playing that is sending a sound to the sound card there, and it has to go through the motherboard to the sound card, and from the sound card to the speakers or the headset, right? So all that message has been sent, all those commands that have been sent from this is a sound card here, right? Sound card is here. You connected that here. So when in the computer you double click that, so the command goes to the processor, but it reaches the processor from where? From these buses, from these very small lines. So processor is talking to RAM, processor talking to display adapter, it is talking to the hard disk connection, SATA connections here, because of these buses, which are lines that carry data. Hey processor, this is a new command, but it's happening in milliseconds at once, done. And processor can process like millions of actions per second. So when it comes to it's mainly calculations that it does per second, but the thing is that if you open multiple applications in the background, there are so many commands going on. So thanks to those buses that the processor receiving those, and buses have speed as well. There are bandwidths there. That newer motherboards would have greater bus speed, which means tasks are even handled much faster, right? Much faster. The tasks are being handled because of the buses, which are very small lines. In the background, it's a full road structure here. In the background, all those are connected to each other, the buses. If you take up that motherboard as well, you will see that they're all in the background. It's all lines and lines and lines and lines, and basically that's how we're connected. Each component is connected to each other component and carrying those commands there. Hey, what's going on between the processor and the motherboard and the RAM, right? So parallel versus serial connectivity, this is how they then go for. There is single data line, and then there is that multiple data lines, and we have seen multiple data lines here. That is just that if you want to use multiple lines to carry some commands faster, or single line to make sure that that command actually reaches, or if it's an older motherboard, you would have that. So motherboard chipset, now there are chipsets there. This is a heatsink here. If I go there, now there are some interesting architectural information about the motherboard, and that is motherboard chipset. See this? There is north bridge and there's a south bridge. So we the north, right? No, not we the north.
Yeah.
We the north, right? We are in the north, actually, right? So it's gonna get snowy as well. So north bridge and south bridge, right? So north bridge of motherboard architecture is nearest to the CPU. South bridge is a bit further to the CPU. What is CPU? Ever heard of that? Something? Okay.
It's a processor.
CPU means?
Central processing.
Yes, central processing unit or processor or professori. No, that's Italiano. Okay. So anyway, this is front bus, and there are backside bus. Those are buses there that are connected to PCIe controller, memory controllers. We still have to know all these types of connections, but understand one thing from this architecture: there are a set of, or a collection of chipsets that help the processor with advanced level of tasks. Again, there are collection of chipsets, and I talked about chipsets. There are chipsets here, and if I just talk about they are very small right now. So if I talk about chipsets here, very small. There are so many here. I mean, if we start noticing those, there are chipsets 1, 2, 3, 4, 5 here, 8 or 9 here, just, and then small chipsets here, small chipsets here. So they are nearest to the CPU or the processor. Why? There are north bridge collection of chipsets that help processor do advanced tasks. South bridge collection of chipsets, which would be away from the processor, away from the CPU, would be doing some lesser critical tasks. So north bridge, critical tasks. South bridge, less critical tasks. For who? For the processor. So north bridge set of collection of chipsets will help the processor do advanced tasks. South bridge set of chipsets will do less critical tasks. That's in plain English, I'm telling. Otherwise, there's a full 2 or 3 chapters in a 1000-page book that talk about how north bridge talks to processor and how south bridge talks to processor. But you should know overall, first of all, that okay, so south bridge is collection of chipsets that really talk to processor. Now I understand that we've been bombarded with a lot of theory here, and we are so excited right now, and we are okay. So the thing is that you're hanging on, and that's really cool. Otherwise, this is theory, and normally I just want to do more practical than theory. This is an IT field. IT field is a practical field. We have to do some practical alongside with theory. In MCSA, in VMware, in cloud courses, we do total hands-on. Total hands-on. It's like click, click, click. Why are we doing this? Why not that? Okay, this, let's click again. So we are totally, full concentration in 4 hours to the topic because we're doing lab, right? That really calls for full concentration on the topic. So, but here I try to go for as much practical to attach it with the theory, just to keep it interesting, as well as we could understand a bit of this. Otherwise, there are a lot of theory here, and I tend to avoid more theoretical courses overall, and I go for wherever there's total hands-on, and pretty much IT is full hands-on. Okay, so we talked about this Northbridge and Southbridge. I'm going to be sending you some more information, in-depth information about Northbridge and Southbridge, and those who are book readers, unlike me. Okay, I also read books only once, and that was enough torture for me. No, it's not torture. It's very interesting to read in the insights of how does it work, how CPU, the biggest chipset on the motherboard, have its army of smaller chipsets to help with more critical tasks and to help it with less critical tasks. So those chipsets are kind of, you can say, army of the processor, right? So but we're going to be touching all those, or we're going to be going more in depth with that. So expansion slot types, there is peripheral component interconnect, PCI slots. I was saying that slots here only, but they are called PCI slots. They what? Which ones? These ones. Wherever you connect display, sound, or network adapter, these are called PCI slots, right? So as soon as somebody says, okay, can you just connect this sound card to a PCI slot? So you would understand, okay, so you want me to connect a sound card to either this slot or this slot. Some motherboards have these 4, some of them have 3, some of them have 2. Depends on the model. What is your real intention? And yesterday we actually connected a card or adapter to a PCI slot, right? And it was like this. In fact, it was not a PCI slot, but PCI slot also you connect a card exactly the way I'm connecting, but this was for display, right? So we connected like that yesterday, right? And so this is how you connect cards on PCI slot. So from the back panel of the computer, you would see there are built-in all the connections, and then there is that vertical connection. This means that it is vertical or horizontal? Vertical, right? So vertical connections are there. This means it's a display router in the back. If you see vertical connections, this means there's a big card that you can take out from the PC as well. But if you see lined up like that, this means that they are built-in connections. You cannot actually take them out. You have to go to BIOS and disable these guys if you want to disable any of this from BIOS, right? But here you can just take it out, right? So that would be from the shape, from the back panel, you would understand, oh, okay, yeah, this I can take out, this I can disable from BIOS. But you have control over everything actually if you know where to go, right? So peripheral component, PCI, then there's PCI Express, PCIe, and then there's PCI Extended. So if we say PCI and PCI Express, so there's that small, really small slot here as well, PCI slot. That is called PCI Express. This is 64-bit. It is faster than these guys here. These guys are older and slower and bigger. The smaller ones are faster and smaller, right? So 32-bit speed is less. 64-bit speed is much more. But oh, sorry, this one, yeah, small one, right? Because I still have to guess where I'm putting my hand. Okay. So here PCIe would be faster, obviously, but when you get a computer, you're like, okay, it's working fine. Now when you go home and actually open your desktop, who have desktops at home? Desktop, laptop. Okay. So we're gonna be experimenting on laptops as well. Oh, there's one. I'm just kidding. So yeah. No, not on this one. Maybe when you are looking somewhere else, then just kidding. So, but laptop has a motherboard as well, has a motherboard like that, but obviously if it has a heatsink like that, you can't have a so heatsink is also very small. Everything is small in a laptop. We're going to see a motherboard of a laptop as well, and you will see, okay, that's pretty different. All components are exactly the same there, it's just that it's just smaller there inside of desktop. So PCI slots are there. So there were older slots there, 16-bit. Then these are just 30. So from here to here, it is all 16-bit, which is much older. You can say one decade ago, or 10 years or 15 years ago, it used to be longer slots. You won't see that in newer motherboards. Then it got smaller, so longer cards were there and they were slower. Then it got smaller, 32-bit slots, and then now it is. So this is the actual smaller, and then smallest is 64-bit slots. It's all about speed there, right? 64-bit would be much speedier. Speed in what? So if you have connected this display adapter, why do you need speed here? For what inside here you need speed? Is it transferring some data? Is it? Yeah. What is it doing?
Transfer data from the device, from the adapter to the screen.
To the screen, exactly. So suppose you installed a game. You know any game? PC game? There's so many games.
Call of Duty.
Call of Duty, exactly. So if you install that game, it's a heavy game. It really needs a 2 GB or 4 GB RAM in the display adapter, right? So when you open that, double click that game, it takes time to load on the memory, right? So it's starting from the hard disk, it is loading on the memory, and when it loads, when you start playing, it needs to show you all the graphics on the monitor screen. So all the data has to travel to show through that display adapter and to show on the monitor screen there. So yes, it really needs speed to show big graphics in in-depth detail, all the graphics, right? So that's why you would need faster components on each level. You would need a PCIe slot, or you would need PCI slot there, and PCI X slots.
What's the difference between PCIe and PCI X?
So PCI X would be, this is the older one, this is 16-bit PCI X. PCI would be 32-bit, and then PCIe would be 64-bit. So that's a lot of speed. 64-bit is nowadays it's all 64-bit. It's by default, it's 64-bit. That was older times, right? But many of the companies where you would be there, and if they are keeping in mind, oh, this person is A+, okay, we have a lot of desktops here, okay. So yeah, if you keep in mind that there were older slots there, PCI slots, PCI X slots, and PCIe slots, so you would know PCI X is the oldest, then PCI 32-bit older, and then newer is PCIe slots. And so these are all PCI slots here. There are, anyone can tell me what is this slot for by the shape of it, by this kind of shape. So there's this shape slot here, and oh yeah, this is a good example. There's a white one and there's a blue one. So blue one is for display, exactly. This blue one has and we connected a display card here. And how do you know it's a display card?
It's got a monitor.
This connector is only for monitor screens, right? If there's this monitor screen, there's this monitor, you can just take out the cable. And obviously, yesterday the cable was there.
It's right here.
Oh, thanks, right? And so this only comes from the monitor screen, right? I think we all know that. At home, if you've connected it to the monitor screen, you would know this type of cable is there. So that is called VGA adapter. We talked about yesterday as well. So, but I'm talking about now what is showing a slot there. There are PCI slots. So what is the purpose of blue one and what is the purpose of white one? They all connect some kind of adapters or cards like this. But as you said, blue one the shape here is green, exactly the shape there, because it grabs that at the end. There's a connector there, there's a lock there. So the blue one is meant for only display cards. It is also called AGP slot, AGP. But others are all PCI slots. But what are others used for? These white ones. Some have, it has also two, but some motherboards have 3, 4, 5, 6 PCI slots. So forget the blue one, which is AGP, which has a grip at the end. Others are very simple one. What does those simple one do? As I said, network card, sound card, and any other. It used to be a modem adapters before. Modem was supposed to connect us to internet. Used to. Now it's DSL cable. It's just DSL lines that are there. So if any of the other types of so there are sound cards there. Normally in motherboards now it's going to be mostly built-in sound cards. This is a built-in sound connection there, right? So, but if you wanted a heavy duty, I used to purchase Creative sound cards from a company called Creative, and those sound cards were wow. So they would really give high quality sound there. But it's all in the past now. So I used to just purchase a card like that and put it in any of the available PCI slots there. So that card would give you so many sound functions and sound, even voice changers or any kind of advanced sound quality functions and features there. So, but nowadays nowadays gamers do that. They purchase, they select a specific type of motherboard. They go through every feature of that, how much it can expand to. 64 GB RAM it can go up to, or 32 GB RAM. There are limitations there. Then what kind of sound card it can take, what kind of speakers that sound card can support, and then the gaming experience overall. How it all goes down to then the motherboard, processor, RAM, and display card for gamers, right? So that's what you need to know about the slots. That there will be slots with a grip, and that would be always for display card, display adapter. And gamers would always have it. That is nowadays. And for cryptocurrency, you want to be extra rich. Get a desktop, get a 4 GB display adapter, install a software for Bitcoin, and good luck. It's already $8,000, right? It's nowadays 8,000, right? So, but those who are doing Bitcoin mining with this, those guys are still working hard. So mining, they give you Bitcoin after like 1 month. But you have to continuously spend your electricity on, keep the computer running and keep their calculations, add your PC to their calculations, and as a reward you will get some portion of Bitcoin. So anyway, so they really go for motherboards, and they really go for what kind of AGP slot, which is just for display adapters. And other slots, normally they are, everything is built in now. But if you want specific service of sound card, specific kind of any other network card, and network card could also be 10 gigabits and 100 gigabits maybe. Network cards that can give a lot of, that can have a lot of data transferred, because in Bitcoin you also need that, right? So these slots you can put extra adapters there. Now I'm gonna be digging down into how many adapters I have there, but there's a lot of motherboards there that we can experiment on. So this is just with the slide we're trying to know PCI slots. Okay, that's good. PCI connectors, then the bandwidth comes here. X1, X4, X8, X16. The main thing is X1 is 5 gigabits per second or 400 megabits per second, and bandwidth for X4 would be 20 gigabits, X8 would be 40 gigabits, and X16 would be 80 gigabits per second. That is huge bandwidth when you put a card there and it goes for that. Now this is small and it's giving you small bidirectional, but that is for PCIe connectors. So that PCIe connector is this, the small one, PCIe connectors. This can expand as well, and they are giving you the expanded type. But this PCIe connectors doesn't have to be exactly small. It can be PCIe and it could be this long as well. But then the bandwidth will be 80 Gbps, which is huge. So according to the shape here, and according to the pin sets here, but if you go for just a shape, that's already that it is showing there. So where is the cut here? the cut here on the inside. So the cards that are made for PCIe cannot be fixed on PCIe. That's not possible, right? So the AGB card here has a cut at the start here, right? So if I want to, can I just place this card here on this slot? Maybe I can, maybe I cannot. So maybe I try, right? So this card we know fixes here, but if I want to fix here, do you think it will fix? Do you think this card will fix on this slot? You're saying no? Are you sure that it's not gonna fix? Are you sure? If I
They're not the same length.
if I fix now, I'll get a coffee from every one of you, right? Yeah. Okay, so I will get a coffee if I fix it now, right? Done? So you win. I can't. So obviously it's your confidence, but obviously you cannot fix it here. So it's PCIe. We would know right away that which card you're purchasing. It will never fit. PCIe card would never fit in PCIe. PCIe card would never fit in PCIe only. Is that what I said? Okay. So we understand that this is PCIe, and it has longer, sizes as well, with huge bandwidth there. So gamers would really love those kind of cards if they have PCIe supported there, right? So that is the way you can just know. Then comes the memory modules, and after the break we're going to talk about memory modules. Woohoo! Oh, since we don't need a break, so let's go ahead, guys. Memory modules is what? You didn't say yes, so I thought that you're so excited to learn more. You don't even need a break now. We're still shy. So this means you don't need break, right? Or you need a break? Okay, there you go. Break. Pausing the video. And we were talking about that who brought the coffee. Okay, so yeah, good. So you needed coffee after that kind of torture. I mean, study or theory, right? So you hurt my feelings now. I said torture. You was yes. What? That was a torture? Okay, just kidding. So okay, guys, here we're talking about RAM. And there is memory modules. There is 30-pin SIM, and then we're going to be talking about DIMM and SIM. What does it mean? But it used to be called SIM 30-pin and 3.5 by 0.75 inch. Then 72-pin SIM. So there was 30-pin SIM. Then there was 72-pin SIM. Then there is 168-pin DIMM, 44-pin SODIMM. Wow, what a name, SODIMM. And then 72-pin SODIMM. So first of all, this is for old computers, 30-pin. And you can see that there is no cut here. Oh, what's going on? Okay, anyway. So there is no cut here, right? But when you go for 72-pin SIM, there's a cut right in the middle. And then there's a 168-pin DIMM. So this is singular inline memory module abbreviation, and that is dual inline memory module, right? But what do they really do? We're going to talk about that too. 72-pin SIM have a cut there, and you can see some chipsets on the SIM here. These are memory modules, and we're just talking about these guys here, right? So you know the functionality already. It stores data permanently when the computer is powered off, right? What? Hey, you saw my expression first, right? That's not fair. So, that was a trap. So it stores data permanently when the computer is powered off. Yes.
Load files.
Huh?
Load files.
False?
Files.
Is it false? Is it false? Is it false? It stores data permanently in RAM. Say false. False. Okay. Just kidding. Okay. So what stores data? Hey, we don't have a garbage disk. Okay. So, oh yeah, there's a disk there that I need to still check out. But what does it do? Quickly. Hmm? Loads applications on that, right? It permanently stores is what? Hard disk. Hard disk is the permanent storage. So we're talking about the RAM, the memory, and then there are types here. Now, I am grabbing that, and you can see the shape here, and you can see the types here. Which one is this there, which I'm holding here? Is it the same? Is it a DIMM? Oh, 72 pin SIM, and then 168 pin DIMM is written there. So does it look like 72 pin, or does it look like 168 pin to you? And how can you say that? How did you compare that from there to here? Okay, anyone, first of all, which one is that? What I'm showing you. This is 72 pin, you're saying? You're saying 72 pin?
Yeah.
No? 72 pin? There is some small comparison here. You think it's 168, right? So why do you think it's 72 pin?
It matches the length.
Length for this, right? And what else?
The cut is exactly.
Cut.
Yeah.
That's where the whole thing is. How many cuts are there for DIMM? Two. SIM has one cut. It has one cut. So it's a DIMM, right? I put a trap on every other statement. So it's a SIM. Okay. So singular inline memory module and dual inline memory module. But yes, we have to be sharp here. And yes, this is not that easy. This cut is not very clear, definitely. So this cut is clear, this cut is not clear, and this cut is clear. There is no cut here, right? Is there a cut here? So if you see a really old RAM that has no cut, it is 30 pin SIM, I'm sure you will never see that. Or either maybe in the museum, but not here. So nowadays this is really common. But what about, you can see the sizes here, right? Can you guess, I'm sure we haven't talked about that yet, but can you guess to which device this RAM or memory module belongs to? If this is the size here and these are the sizes here, and I can tell you now these belong to desktops because I'm having that one, and you yesterday attached it to a motherboard that belongs to a desktop. So these memory modules are smaller than these. Where would they be? Okay, that was easy. Why was I just creating so much longer questions here when I could have just said, hey, what do they belong to? Okay, so thank you, that was good. So they belong to definitely laptops. So DIMM or SIM belongs to desktops, SODIMM belongs to laptops. So when you go to Canada Computers, can you give me SODIMM? And they were like, oh, what? SODIMM. Again, what? Okay, memory for a laptop. Oh, that's what you want. Okay, sir, sure. No, not all will know that, but those are technicians, those are engineers, right? So try that on them. Oh, why didn't I have that idea? I'll tell them, hey, can you give me SODIMM? Okay, I'm sure they will know that because they hire those who have gone through A+, who have the certification of A+, and initial salaries are good. Canada Computers, Staples, they all need that, and all companies, they have their departments, level 1 desktop support, so you would know that and they would ask you. So that's one thing, but there is more to that. SDRAM, 168 pins, 184 DDR RAM. So there is SDR, SDRAM, and we're going to be talking about the history of that as well. DDR, SDRAM, 184 pins, and then there is DDR2 SDRAM, 240 pins, DDR3 SDRAM, 240 pins. Now, these DDR3 is the one that nowadays we're using. DDR3 with 240 pins is what we're using nowadays. But what is SDR? What is DDR? Now they are introducing names there, but there's a separate RAM topic where we're just talking about RAM, memory, history of that, and then how SDR, DDR fits into the equation. So we're going to be talking in depth with that. But you must know that there are these terminologies that are available there in the market. So in the previous diagram, I was talking about until or up till 168 pin here, but now it goes to it starts with 168. So this means the previous one is talking about 30 pin, 72 pin, which are obsolete now, and you would just see DIMMs from onwards in the market. Even you won't have 168 pin DIMM there. You would straightforward see these 184, 240, 240 pins. So DDR2, so DDR3 RAM, I can tell you that for my laptop that DDR3 fits into that laptop where it can go up to 32 GB RAM capacity. DDR2, it can go up to 16 GB RAM, right? And 64 GB RAM laptops, those are wow laptops nowadays. 64 GB RAM they can support, and those are called DDR4, right? So if it supports 64 GB RAM, which is a lot for gamers, it's a heaven, right? Well, you know, they would just go for more. Anyway, so now we're talking about, first we briefly talked about RAM there, and we talked about there are DIMMs there because there are separate sites just for RAM. There's a separate site just for processor. There's a separate site just for hard disk, and separate for the whole computer. But this is just introduction again. But we go a little deeper now, and while I'm showing you as well that what are these. Then with the processor example memory capacities, in fact that's just still example capacity. There's L1 cache 64 KB, L2 cache 256 KB, L3 cache 4 MB, 12 MB, RAM 4 GB to 16 GB, HDD, SSD, SDD actually hundreds of gigabits of GBs or 2 terabytes. Now they are talking about memory capacity. How do you use this terminology? Memory for motherboard, you can use that terminology, and you can use the memory for RAM. So and then you can use hard disk, memory in the hard disk as well. Where, in which areas do you use the word memory? That's what this slide is talking about. And I wanted to show you about, because they mentioned the word L1 cache, L2 cache. So strange that this means this is an older motherboard, because so guys, processors have cache. Now we talked about cache already. What is cache? Cache is there now. Storing data locally, exactly as you said, for the purpose of retrieving it faster. That's the main. So you cache data, what happens? You cache data, next time the data should not be retrieved from some far off device. It should be retrieved from that cached local area. So when you cache data, it is always supposed to be for real fast access, very fast access, right? So L1 cache, L2 cache, L3 cache. This is helper memory for the processor. It is memory, but it is for specifically dedicated for processors. So if someone asks you, hey, you got a new PC, what is the cache there? And you say, hey, it has L1, L2, L3 cache. So the guy would ask, hey, since you're A+, so can you tell me what is cache? What does it do really? So the processor has L1, L2, L3 cache. First of all, I would show you that what can you see that? So within the processor, see this? Within the processor, you would see very tiny chipset there, very tiny chipset. Now I'm gonna within that. So please see and forward that. So see the tiny chipset. So everyone would see that up close. Tiny chipset, silver chipset, right? These are all L1, L2, L3 cache. But what does it do? Yeah. So cache, right? Okay, thank you, man. So here, this L1, L2 cache, when the processors are receiving commands, those commands have to be stored somewhere. So example of command, you open MS Word document, the command is there you open Excel document, command is there, you open actually 5 or 6 extra Word document, 6 or 7 Excel document, 10 websites you have opened. So browser is heavily using processor. The commands are coming from all sides, numerous applications are open. Then there's a sound, there's a movie in the background or song in the background is being played. So you would see that processor is receiving a lot of requests. Hey, start this application. Hey, start that application. Hey, start this sound card. Hey, start this, start that. So all these commands are queuing up in cache. If you have L1, L2, L3 cache, processor queues those commands there. Okay, I need to do this. Can you just wait inside that L1 cache or L2 cache or L3 cache, and let me just execute these commands first, which I have received already. I'm opening a MS Word there, and there is a request for opening 3 other instances of MS Excel and browser there. So those requests to open applications are quickly saved in cache, and as soon as the first request is executed, the next request executed, and this is all happening in milliseconds, in seconds, or a bit more than seconds at once. But those commands, now imagine that this cache with graphics adapter for gamers, when one graphic is loading, that could be having hundreds of requests just to load one detailed picture there. There could be hundreds of requests behind working for that, right? So those requests, then sound requests, then all the other applications in the background that are open, messengers are open. So all these requests needs to be executed by the processor. So it needs to queue them up in cache, right? So if you have more L1, L2, L3 cache, the processor is executing everything in speed, right? And pretty much, this is an old motherboard, right? So there are higher capacities of cache available. So remember one thing: L1, L2, L3 cache are helper memory for CPU. L1, L2, L3 cache is helper memory for CPU, right? So CPU is executing commands. These commands are being executed when those commands are actually queued up in L1, L2, L3 cache, right? So I'll be throwing questions at you all of a sudden. So with traps, I love traps, right? Okay. So if I say something and you say yes right away, that's it. One coffee. Just kidding. Or one. No, I was gonna say biryani, but then you don't know what is biryani, right? You know biryani. Sahan restaurant. Okay. How about that? Don't tell me you don't know Sahan restaurant. I go there regularly. Okay, so I'll give that address here. Don't worry. When I put a trap and you say yes, exactly, this means you were not listening, and I read a wrong statement. And you said yes, you're correct. This means the map of the restaurant here comes, right? Okay, so now let's just go ahead. We understand L1, L2, L3 cache. Maybe in next class or next week, before next week, you might get a quiz. MS Word quiz, and there's question number 1, 2, 3, 4, 5, 6, 7, 8, which we have discussed. I'll be sharing the video with you. Listen to the video, get the answers, or it's an open book, or open internet. Just Google it. What does cache do? Or I'll just put true and false. That's always the most trickiest. Is it true or is it false? So you might get that, or when you sit in the class, next class, you might get a quiz right away, or whatever we've discussed here, right? So solve it in least amount of time. So guys, about the class schedule, one more thing. Tomorrow is which class? Huh? Network Plus. Oh, you know the new schedule? So there were supposed to be 3 A plus class and 2 Network Plus class during the week. Now there are 2 A plus class, 2 Network Plus class. Friday is off. Which is good, right? Did we not talk about it at the start of the class? I think we did. Oh, we did not. Okay. So yeah, 2 A plus and 2 Network Plus classes, and Friday is off. Yeah, we talked about it. You were actually happy on that, right? Oh, okay. Still happy on that. So, hey guys. So tomorrow is a Network Plus class, right? So it's like basics, and you're going for CCNA. You will be like, hey, teach, this is basics. I'm in CCNA. Give me some advanced stuff. So you'll be like bored to death. Ah, really? You're talking about the basics of network. But doing that exam would really attract recruiters, especially A plus. You have to do that right away after you're done with the course. A plus is a must. Okay, so but Network Plus, if you have done CCNA, that is better than Network Plus. But A plus, there is no alternative for that. This is very critical if you want to enter the job market. You want to go for some quick job, then and there. A plus plus if you have MCSA and CCNA, at least the pay will be better. You'll get a job, but pay will be better, right? So, okay, guys.
CSE.
That's 5 exams. MCSA is 3 exam. MCSA 3, MCSE 5. So since I recommend that, go for VMware for virtualization in depth, cloud, Office 365 for also cloud applications, and then MCSA, and then A plus and CCNA. So that's 6 or 7 certifications. So normally I ask that stick to MCSA, the 3 exams. If you go for MCSE, that's even better. But A is good enough when you're doing so many other things. That's what it was. Alright guys, so RAM 4GB to 16GB, now it's 4GB to actually 64GB. So this slide may be a little older. It's not maybe, it's 2015. So, but this never changes. L1, L2, L3 cache is in 2019 or in 2025 will still remain the same. RAM history will still remain the same. So that's why in the books that you have, I hope you've all ordered the books already. Yeah, okay, so let's go ahead. Let's not ask that question. So, hey, you were planning to purchase a book, right?
I have it.
You have it already?
Yeah.
Ah, you're well prepared actually. Bring it on, this means. Okay, that's good. 1001?
I think I have 901.
901, okay. You know what? Hardware in 1001 and 901 is same. And at least 80% is same. Some which is different, we're gonna cover that here, which is all software actually. But
What is the HDD and SDD?
oh, that is HDD is hard disk drive, right? But this is 100 GBs, and this is not supposed to be SDD. This is supposed to be SSD. Say, solid state drive. So
That's a flash. That's basically a flash.
yes, exactly. All chipsets, not platters. In SDD there's platters, and I've lost so many SDDs because of laptop dropped while it was working, and the disk was like tuck tuck tuck. Sound starts coming. This means bye bye, gone. I wish I had backup. So, but SSD, your laptop is dropped from this height, or I just, while the laptop is powered on with SSD, I just throw the laptop to my friend carefully, and he caught it. So still, SSD is all chip. It's not platters. We're gonna talk about that. What is platters, not chip? But SSD is chip, so it doesn't get damaged with some sudden movements, or if the laptop actually drops. SSD is pretty safe bet, but try not to drop. Right? Okay. So we talked about CPUs under heat sinks, right? And why they are under heat sink, we understand that already, and we talked about that. They should be with heat sink because heat sink is required because
There's a lot of heat.
no, heat sink does what? Absorb heat, right? So whatever heat is being produced by CPU, central processing unit, is being absorbed by heat sink, so it remains cool, right? So but the fan, so heat sink plus fan is even better, obviously, right? So now they're talking about processor, and I see that there's a heat sink plus processor there, and I'm so tempted to ask you to take out the processor and put it back.
Bro, sometimes in the heat sink, sometimes there's a water through the.
Oh wow, that is for heavy duty gamer desktops.
it gets cooled by water.
That's expensive, really. And yes, it's for those processors where you're expecting a really enterprise grade application or a big game. So that's something not very common for really professional gamers, big applications. So, okay, guys, then CPU sockets, we talked about that. And what is this? Or this, or this, or this, which is, I'm pointing at the same thing.
Cache.
Really? Are you sure? Do you agree that is this the cache? Or is this chipset, or this chipset within the socket, a cache or cache? Is it? So you say yes. You yes, yes. When you say and yes, that is not confidence. Yes. Okay. Sure. Which cache? There are three types there. Like L1, L2, L3 cache, and these are exactly as you said. So we just saw that in the socket, and those are the cache that. So cache does what for the processor? Stores those commands that the processor needs to execute. In fact, queues up those commands would be even better. Queues up the commands that need to be executed, right? So okay, then comes a lot of types of sockets there. This is still a kind of day one, day two data there that we are giving going a little deeper, but then separate slides open for one particular topic, and then we go really deep then. But this is just the types of LGA 775 socket, then socket H, H2, H3B, and socket R, then AM3, AM3 plus. That's just the types. How they are different, we're going to be talking in separate slide on that. So, but okay, I think I've put that here already. Normally I'm supposed to put it on a separate slide there. Okay, so Intel produces a family of processors. Intel creates family of processors, and when you see that name here, Sandy Bridge or Ivy Bridge, right? And Haswell E, Sandy Bridge, Ivy Bridge, Haswell. So these are families of processors. When we say family of processors, what do you take from that? What do you mean by that? Family of processors? So this means that, yeah, so some common features are there, and the processors are maybe every 2 year 3 years they are coming up with a processor with a newer feature, but that feature, some fundamental architecture is same among 5 or 6 releases of the processors. So that is called family of processors. That, okay, major features are pretty much same in terms of architecture as well, but some of the features are newer in the newer releases of the same family, right? So there are at least 8 or 9 families, Italian mafia families, not those, not those. Okay, so these are processor families, and now the models relate to then what families they were released in, and what are the speeds they are supporting there. P4 Extreme single core and dual core, Pentium D, Celeron. Maybe you've heard that before, these type of wordings. Celeron, oh, I have a core 2 dual processor here, or core 2 extreme processor here, core 2 quad processor here, and Xeon and Celeron, and 4X's and EXXS series. So normally what happens is that word core really is important when we talk about processors. Dual core, quad core. And I may have mentioned that before as well in a processor, that if you see quad core, what does that mean in a processor? Quad core means what in a processor?
4 cores.
4 cores of a processor. But what does that mean?
It's split up into 4 parts, and each part is its individual processor.
Mm. This means you did this course before as well somewhere. So, just kidding. So yes, exactly as you said. So if I just take a processor's picture, and hey, there's that complementary metal oxide semiconductor. Whoa. Okay. So yeah, let me just go to the processor and talk about core, and then what is hyperthreading. If you know that much there. Okay. So what is hyperthreading? So yeah, you're caught now. You were saying this. This means now you have to tell me what is hyperthreading.
I'm gonna assume because hyper means a lot.
Hyper. Yeah. In a party, you know, some of my friends go hyper. They're like, ah, yeah. So, but hyper threading. What is threads? So I'm about to explain that. But yes, as you said that it would be performing even more than before. Exactly as you said that. And how? I'm gonna just show you quickly now. If this is a processor here, Core 2 Duo, Intel Pentium 4, that's even older than that. And oh, there's that picture of. Oh, we already attached the processor, right? So I'm just gonna go for this CPU, and thank you for borrowing that picture. So hyperthreading and cores, how do they fit in when we talk about processors? So this is a processor here, and now if I just say quad core, so it would be 4 sections, we can say. Now it is just one processor that you place in a socket on a motherboard physically, but when you say it's a quad core processor, so it would be 4 sections that will be used as 4 independent processors. That's what we talked before as well. Quad core. Dual core, 2 sections. So it means one physical processor, but the 2 sections are used as 2 independent processors. Now here 4 sections. Now what when we say that 4 independent processors, so what's the big deal with that? So what? If there are 4 processors, what really is the benefit there? Can you give me an example of 4 processors being used right now? What is happening? It's so 4 processors are doing the task at the same time. Simultaneous, 4 processors are receiving requests from all around the PC. Whatever you're starting, suppose you start one application. In the background, some applications actually load many components of the applications. One application, you think it's one application just giving one command to the processor, please power it on. No, there are many components in the background that are requesting to be opened as well as part of the application. So processor is receiving maybe 20 commands there for just opening one application there. It could be 30 commands. A game is loading, so the graphics need to be loaded, the sound need to be loaded, some high definition components need to be activated as well. So there are many commands behind one game that are coming to a processor, right? So quad core would really play its part. So all those, suppose there are 200 commands coming to the processor to be executed in 1 second. So 4 processors will take that command instead of one physical processor. 4 core means 4 sections, so 4 processors will all, the 200 commands will be distributed among 4 sections of the same processor. But then comes hyperthreading. What does that mean? So 4 cores here, okay, 4 sections posing as 4 independent processors. Hyperthreading just makes it even better. It turns it into, each section is divided further. So now you're dividing this section, one processor here, one processor here. You divide further this core, you divide further this core, you divide further this core. Okay, how many independent CPUs now you have? They are all independent CPUs now. How many? 8. So you have 2. So hyperthreading makes it possible that 4 cores will be further divided. Each core will be further divided into one independent processor. So when there's a heavy application working, so its commands will be coming to this section, one full independent processor, this section, this section, this section. So there are 8 processors working simultaneously executing the commands. So quad-core processor will become 8-core processor, right? And enterprise applications, now that's why I say that if you're in the field of IT, you need to first start with a good hardware. Plan it, right? So majority of the students here, when we start the course, on day one I say that you want to survive in this field, get a good hardware first, right? So because you need to create many virtual environments there, big environments, 4 virtual machines, 5 virtual machines, 10 virtual machines there. Those 10 virtual machines are like 10 servers here, 10 machines which are separately here. In virtual environment, you can have all those 10 machines working at the same time, but they need a lot of RAM, a lot of processing, a lot of hard disk space. So this is a quad-core laptop, right? And I bought it as a refurbished. Nearly here 30-40 students have bought that in different courses. Day one is career talk, right? I didn't do that talk here actually with A+ because it's all hardware, but you want to stay in the field of IT, maybe you want to go for cloud courses later, right? It's not maybe, you will have to. If you want to survive in the field of IT, you have to be learning cloud courses. One day, either you will learn the hard way, I should have done the cloud courses, or plan it now. But if you are planning it, get a good hardware first, right? So laptop, quad-core, i7 quad-core, good enough. It supports 32 GB RAM maximum, but you can create virtual environments there, VMware environments there, Citrix environment, that is another enterprise application. And you know, when you talk about cloud, so many of the applications need to be downloaded and tested and then uploaded again. When you download that application, the hardware has 4 GB RAM, you're stuck. You can't do anything now. So your hardware has to be good if you want to survive in the field of IT. So plan a i7 quad-core processor and 32 GB RAM. Right? That is, put it in the plan, put it in the mind. I need to have a desktop or a laptop that, and this is a refurbished one, $900 I think. The new one would be $2,000, $2,500, $3,000. So all students bought it from NetPlus or Kijiji, Go Kijiji, or there are some refurbished shops everywhere where you can get a laptop with i7 quad-core. After that, you're ready to test all the advanced concepts, all the advanced applications. That's where all the jobs are, right? So quad-core processor is what you really need to really survive in the field of IT. You want to stay there in the field, you need that good hardware first, right? So we understand that 4 cores, just 4 independent processors, and hyper-threading makes it 8 cores, 8 independent processors simultaneously receiving the requests, right? So this means your enterprise applications will be working really fast. There are 16 cores in servers, 16 cores, right? Or 32 cores. Wow, that would be like 32 cores. So, but the applications are in banks. They have data centers and they have 100,000 users. Yes, 32 cores, multiple servers. 32 core would be like just the motherboard would be $5,000 or $10,000, right? So one server would be $20,000 or $25,000. Otherwise, these servers back there are $2,000, $3,000. But those servers would be, with 1 terabyte RAM. 1 terabyte is huge, right? I'm like saying, hey, this is 32 GB RAM, 32 GB RAM, and I'm like this. That's 1 terabyte. Alone RAM would be $5,000, $6,000 or $8,000. So they have heavy computers there with all kinds of. But if you know what your applications will do, if you know that your applications, banking applications, will connect 100,000 users there, throughout the peak time or daytime, right? So you need these kind of processors, RAM, and hard disk space, especially SSD drives, solid state drive, which really goes fast. So we're talking about hybrid threading and 4 cores. This means that I'm going to throw that question to you anytime during the course, right? So if we go back to this, so these were the different models of the processors that are there. And then there's Sandy Bridge, Ivy Bridge. Sandy Bridge has 4 or 5 types of processors with different architecture inside, and Ivy Bridge would have that. So we're going to be talking still in detail with pictures and all, but right now it says that these are the Intel models. So what is the other vendor that creates processors on the planet Earth? Intel creates processors, yes, I know.
Apple.
Mm-hmm.
Apple doesn't create the processor.
Processors, no. Systems, yes, and they get the processors from those who are specialized in only creating processors.
What about if the Apple, it's called the
There are only two vendors on planet Earth that create processors. One is Intel, one is... Okay, Google it.
So in a quad-core processor, if one of the processors breaks because it's independent, is the processor itself still able to work?
Sorry again?
So because there's 4 independent processors
Yep.
on the quad-core, if one of the processor sides breaks, does the other 3 still work? Or do you need
Yeah, yeah. So when you say one of them breaks, so either it will break physically. If it physically breaks down, or the socket has some problem, or the processor chip has a problem, the whole thing will be gone. So, but those are logical sections created in the processor, which are cores created there, right? So it's either gonna break or it's gonna work. There's no section breaking.
Qualcomm.
Qualcomm, okay. So the major vendors, Qualcomm is one of the companies that are making processors also for cell phones, for other devices as well.
Samsung.
Yeah, for Samsung. So thing is that there are two vendors who create processors on the planet Earth. One is Intel, one is AMD. AMD is the other rival of Intel that makes processors, that specializes in processors, right? So you will either see in the market laptops, desktops, servers, either they are having processors of Intel, which is more popular, or from AMD, which is a bit less popular, but really it has huge customer base. Okay, there you go. So AMD processors and sockets here. Normally I think we will have all Intel here. Intel is main. But you would see that some, if you're about to purchase a laptop or a desktop, don't go for AMD. So Intel is much better. But it's not much better, it's just much better. So it's not that bad as well. AMD is also okay. But when we have seen performances, students brought their AMD based laptops, processor based laptops, and Intel. So Intel was, clearly giving better performance. But it's not like unacceptable with AMD. AMD is also okay. But the other vendor is, we should know. So there's that AMD processors and sockets, socket type. They just have different names, obviously. Number of pins: 941, 942, 905, 904, 906. They still have pins there. While the latest Intel processors, they are pinless. And I've shown you that diagram. We have the pin processors there, which you already saw. But AMD, they all have pins. I'm sure they would have the latest model as pinless, I'm sure. But it's just showing how many pins are there. And they just call it Phenom 2, Athlon 2, Sempron, Opteron, and Megatron, right? Oh. What? Transformers. My kids make me see that every day. Torture. Okay. Bumblebee. Oh, okay. So here, socket AN3 plus, socket FM1, socket FM2. So these are the types of processors. We just need to know that, and that that's the other big brand other than Intel. It's AMD, right? So, and it has also 2 socket, 4 socket. I've shown you the picture of 4 socket as well. That would be a very expensive motherboard if you're going for 4 socket. That makes it 32 core. One socket can support quad core. Suppose there are 4 sockets that are supporting, each supporting quad core. How much that were? Whose maths is good?
82.
Okay, that was not very difficult. So if there are 4 sockets, each quad core, so there would be 8 times 4, right? So ADX power. Oh, looks familiar, or did we just handle that today? Yes. So this is the power for the hard disk drive. It connects to the hard disk only, right? It's not the main power, right? Okay, you got it. So this time I was trying to be serious, that I'm not going to give away the expression that, oh, okay, you're kidding, right? So okay, you got it. So this is for what? Quick. For main power of the motherboard. But I asked you to plug and unplug that. So since you did that, so you should know that. already. This is not for the hard disk, this is for the whole motherboard, right? Motherboard ADX power. Then comes the firmware. We talked about the firmware. I showed you that it's the BIOS, so software encoded in hardware, often implemented on read-only memory or ROM chips. Read-only memory or ROM chips. Now found in computers, printers, etc. Common example: computers, BIOS. So firmware is a software that is installed in the BIOS chip, right? It's a chip in which whatever settings you have seen there is called firmware. So in the company's bosses say, hey, can you upgrade the firmware of this computer? I'm trying to connect a 2 terabyte external drive and it's not detecting that. So I read the manual and it says that if you update your firmware for this main motherboard, so it will support newer, much bigger capacity hard disks as well, right? So firmware just means upgrade the software of BIOS, upgrade the brain of your computer. That is called firmware, right? So found on adapters for SCSI, graphics, etc. So this firmware is just giving you the settings of the brain of the computer, which is BIOS, right? BIOS chip and Cmos battery, we talked about that. Woo! And I showed you as well. So it looks like this, and we took it out, and it's this is the BIOS chip here. Actually, BIOS chip, it actually says here BIOS, right? So can you locate that as quick as possible? Exactly where is BIOS? I'm gonna bring two more motherboards now, and you can all locate. Okay. You see that BIOS written there. Or even if literally the BIOS is not written there, the chip exactly should look like that. Can you locate that on a motherboard? Similar or near to that even would work. Near, just near. It could be very small. It could be, no, it will be small. You found it? Wow, that was fast. What's right with you, man? This one, right? But do you see any other chip exactly like that anywhere else on the board? Exactly like that. What about this one? Does this look the same, or does this look the same as this? Or any one of those have a BIOS written there? You can use your magnifying glass from your cell phone, but if we have a magnifying feature app on cell phone. No, right? Like literally BIOS is not written there. Does it nearly look like that? Any of the chip that you locate is nearly looking like this chip? No? Really? If I located that, then yes, sir. So you were able to find it. Yeah, yes, it's this one. Is there any other chip that exactly looks like this? So just this one, and there's this one as well. Yeah. So normally it's not really clear in all motherboards. Normally it's not very clear in all motherboards. If it says BIOS, we're good.
If it does, it's too small. Oh,
Yes, true. Normally, when I used to have motherboards there in my computer shop, I used to have a lamp and obviously a magnifying glass. Or nowadays, people just take a picture and then they zoom the picture, and the picture just shows the writing. If you look at the BIOS, wow. So no, right? it's the chip literally doesn't have to look like that, but one of the chips with very small writing normally is or has been caught as a BIOS chip. But how do you suppose the boss really need to locate that BIOS chip? The boss says, no, tell me where it is. So the easier way would be that if it was a newer company board, I would just go to the website, I would download the manual, and I would look at the chip right away. That, okay, this exact chip is the BIOS chip. But like this, that I wanted you to see that it's not very always clear that you would actually see literally chip written with BIOS on top of that, right? So you were not, no one was able to see at least BIOS written there, right? No one was able to see that, right? But the chip, some of the chips do look like that from the surroundings, right? But so if I just go for one more example here, which is, we can go for, so BIOS chip on the ADX motherboard. Images. Okay, so there is another way to see that too, and you can see this AMI BIOS, and you can see it's like a capacitor, and then there's BIOS here, there's BIOS. So there are different types of shapes there for the BIOS. Are you able to locate like this, or like a long one? There's a longer chipset here. If I go and show some more examples here, oh yeah, it could be coming in any shape, because this kind of chipset you can see easily on your motherboard, which is like that, this kind of chipset, right? So it's not really very clear, but it can look like any of those shapes as well, right? So if we had to locate better, we should have those magnifying glass. So your task would be to grab from that Dollar Party or Dollarama magnifying glass, or from Staples, and come back here and just get it. No, you don't have to. It's like, hey, Teach told me to go to Dollarama and go for a magnifying glass, so next class we will be locating the chip. Seriously? Okay. So, but the chips are there, chipsets are there. You won't be able to see that easily. In some you are able to, but when you locate that, sometimes if on the motherboard level there is some problem, so with magnifying glass we just tend to locate, okay, where's the BIOS chip there, and how is it really working. So okay, we were not able to, but it comes in these kind of shapes there on the motherboard, and this is we're talking about the brain of the computer. The firmware is the software that is installed in this kind of chipset, and we were configuring, I was showing you that firmware when we were configuring the boot sequence, right? And we were configuring, I can disable all the hard disk there, and then suppose I go to the friend's house and he's not around, and I open that disable, and he's about to show me a new hard disk there, and he's connecting, and seriously it's not detecting. What happened? Okay, let me fix that. Go ahead. So anyway, the thing is that with BIOS you can just pretty much control the whole computer. So BIOS chip and the Cmos battery, we already know the battery there, and so flashing the BIOS only when necessary, use only manufacturer utilities, and for firmware don't lose power. So flashing just means what? Upgrading the BIOS. So the example would be that you have some newer external USB, and that's not detecting with your computer. So you have to upgrade your BIOS to detect newer devices to connect, right? Maybe the company has created that newer features there that would upgrade that. So the fan is not working there, right? And you don't want that fan as well, right? You're good, right? With the fan, you're good. So because that's really anyone is okay if I just close that? Everyone's okay if I close that fan, or you good? You good? You good? Okay. My coffee, I am about to put ice cubes there. It's so cold now. Oh, it was on full. Okay. So
This one isn't working?
this is working.
This one?
Yeah, if you just turn on. If you want to turn on, are you okay with that?
Yeah.
Yeah, the slow. Yeah, this is the slow one. All right, guys. So we're talking about. Okay, let's not go Italian. Watch a lot of movies. So anyway, so BIOS boot screen during post. Now, post is a process. Ever heard of post before? You post a letter, right? No, not that post. Oh, you heard about post. What is?
Well, it's an acronym, but I can't remember.
But what does it do? We always skip to what does it do. Abbreviation is like.
What does it do?
Okay, so post. But you heard that.
Startup, yeah.
Ah, yes. So post is power on self test. Power on self test. So what does that mean?
It's like a ping. Is that?
Okay, test the network, you test with ping, but power on self test means what? It's detecting. So detect, do you have a hard disk? Can you connect to it? Do you have a RAM? Can you connect to it? Do you have a display card, processor? Can you connect to all these devices? During the power on, it tests itself that everything is okay. Let's power on the operating system. But before powering on the operating system, it tests its hardware one by one. That is post process, right? So BIOS boot screen during post process. It says here AMI BIOS. So BIOS version number, American Megatrends Incorporation, and the date. So when you start the computer, the many computers show the actual BIOS company vendor name and the date of manufacturer and the model of the BIOS. Many computers show that when you start the computers, right? So when I started that virtual machine, I don't think it's gonna show the BIOS, but see, now we all need virtual machines. So in next class, I'll be asking them to next A+ class. In fact, the Network Plus also, we need to be in the other room. You need to have your own computer machines there, so we could install some virtual machines and then we can talk about networks there, right? Even we have to go for packet tracer with basics. I know you'll be bored to death. I understand that. Okay. But with computer room, that's the one bad thing about that is that it has internet connection, then it has Facebook, then it has YouTube. And I'm sure you're not going to go there, right? Okay. So here, I have a software that connects to any screen and shows it on the board right away. I wish I had that. Okay. So, no, I know some software that can do that, and that was so much fun. Many students, when I'm talking serious topic, and they're like, and they're sitting on the screen and they're, okay, he's seeing a joke, and I'm really explaining a very critical topic here. So, okay. So let's go ahead. So if when you are in that lab, try not to laugh at a funny joke during the class. I will know that. Oh, okay. So, so here, power on self-test, that post-process. So every machine, you won't see that in every machine because there's an option in BIOS that says that do you want to hide the post-process as well? And you can just select that option in BIOS, it will hide the post-process. Then it will not show you that it is checking hard disk, CD-ROM, RAM, everything is checking. So it's not going to tell you anything actually. So if we go for the next now, in the BIOS, what do you exactly do in BIOS? Settings saved in CMOS, date, time, drive configuration, memory, CPU settings, integrate ports, boot sequence, power management, virtualization support, very, very important. Suppose I ask you to, you got a new laptop now, and I ask you, can you start a virtual machine? So virtual machine is just like a physical machine you install, and we're going to install virtual machine there as well. So, but it's not going to work. When you purchase a new laptop or desktop, or the first time you're installing the Vmware Workstation software, and you install a virtual machine, it will not work. Because a new machine, you have to go to the BIOS, you have to enable virtualization there. It's always the case. You have to go inside the BIOS, enable the virtualization yourself manually in every new machine. then it will let you start the virtual machine process. So we're going to be installing virtual machines in next class. We're going to be installing the operating system there. I'm going to talk about then many of the things related to A plus as well, and Network Plus. Oh, okay. Tomorrow I think we need to go to that home. So I will ask Mazarik to, if tomorrow, Thursday, Friday, Wednesday, Thursday, I need to check that if that room is not taken already. I need computers. Okay, so security, passwords, trusted platform module, settings, and low jack. So, well, low jack. So, passwords we understand in BIOS. Ever heard of TPM before? Trusted platform module. Ever heard of encryption before? What is encryption? What does it do?
It makes data unreadable.
Hey, did we not talk in the last class as well? Encryption. And maybe we talked about TPM as well. Hey, we talked about TPM, yeah. So, yeah, what is TPM? What?
No, we didn't.
We didn't? We didn't? I remember.
Mentioned encryption, but you
TPM. Yeah, we did. So, that's
a trusted platform module. That's like a face unlock or like a fingerprint.
we talked about security at that time, yes. In the security we talked about, because I remember that. So, fingerprinting, that was biometric, but TPM is a bit separate.
That's when you, is that when you only let certain, no, it's not when you take only certain MAC addresses into,
Oh, that is for Wi-Fi,
yeah.
for SSID, but this is for encryption. So yeah, that is different. This is different. So if we, I'm just gonna quickly show that concept, and once you see in diagram, you would understand right away. Because next class I'm going to be asking you. Okay, that's the fun part. So TPM is, if you have a machine here. So let me just grab a machine first of all, and let's just grab HP desktop. Workstation. Okay, images, and then we go for, okay, which one do you want? Okay, take this. No problem, thank you, you're welcome. Okay, so if you have this and TPM, when do we use TPM? That's about this. Now you have a hard disk connected to that, and we have a diagram for, or picture for hard disk already here, and that is coming one day, Monday or Sunday. Seriously, I never took a hard disk picture. Okay, so hard disk drive computer, I think I did. Okay, maybe I missed it. So images. Now suppose you have a hard disk drive. Inside it looks like this with a platter, and that hard disk is inside this computer now. So what happens is, this is very secure data. Suppose you have a lot of data, and your boss says, hey, you're going to put that data at your home, you better encrypt it. So you say that, yes sir, I will be encrypting all my disk data. So you do that. Then, remember with encryption, one thing, you have a key to encrypt and a key to decrypt the data. Encrypt means lock, decrypt means unlock. So if you want to see the data, you need to decrypt it. Encrypted data you cannot read, you cannot understand, right? So the key is just, it's just a small file. It's a file, a small file. File is called a key. If and that file will have your decryption password, right? And that file physically has to be there. So the key, a file with encryption, decryption, passphrase is stored in a physical chip on a motherboard. Physical chip on a motherboard. What does that mean? So you can export the encryption key and take it in your USB stick. Connect a USB stick, export that file. Now in that USB stick, you can decrypt that file. If that USB stick goes to the in wrong hands and they really want that company data that you have, they can just use that file and they can decrypt your data if they know the password as well, right? So what happens is, that if you have encrypted the data, so the key is stored in a chipset on motherboard, and that chipset is called TPM. TPM is a chipset that stores encryption decryption keys. Encryption decryption keys, right? So TPM is a chipset that stores encryption decryption keys. Now it's in the motherboard. So what's the benefit of it? So what? What's the big deal here? Now if your hard disk is stolen, somebody took out the hard disk, hard disk from the computer and ran. So this is a small thing. You can just hide it in the pocket. Computer, you're like, you're taking the computer. Anyone would spot you. But hard disk, you take it out. That's it. Nobody can spot you, right? Spot whoever has stolen, right? Not like you and me. Okay. So the thing is, the key is in the motherboard to decrypt. That's the main security. The key to decrypt is not in the hard disk. It's in that motherboard, and motherboard is connected to this computer. Somebody took away the hard disk, but didn't know that its decryption keys in a chipset in the motherboard. So your hard disk is just encrypted. That's it. You cannot decrypt it until you attach the hard disk back to this computer. You have to attach it. It will check the key, then it will decrypt, and it will let you read the data. Hacker needs that data. So if it takes out the hard disk, this is for hard disk protection, and normally this happens a lot with laptops and desktops. CEO laptop in some meeting, and he or she went away, and somebody just took out the hard disk. It was really easy. Took it out and take a hard disk, put it back, or put some other hard disk there, right? And he or she will not know that, oh, hard disk changed or somebody changed anything until he or she powers on the PC or laptop. But when you took the hard disk, its key is in the motherboard. So TPM is that chipset which stores encryption decryption key on the motherboard. So TPM is the chipset that stores encryption key on the motherboard. That's on the motherboard. So next time when I ask, I hope you are able to tell me what is that on the motherboard. So it's a physical chipset. Chipset is always physical, obviously. So the encryption decryption key. So this is for the protection of the hard disk, especially from the laptops. But every computer, your computer at home right now, most probably they have TPM chipset. If you want to, enable encryption now at your home in your hard disk, so the key will be stored in the TPM. But does it have TPM? Your Windows. Anyone has Windows 7 at home, or everyone has Windows 10 at home in your laptops or desktops? Windows 10, Windows 10, Windows 10, 7, XP. Oh, Mac, yeah. Mac would support its own version of TPM. And Windows 10, 7, 10, 8, which one you have? Windows 9. Okay.
I'm not sure.
See this expression here?
I'm not sure which one.
Okay, yeah. Okay. So there's no 9. There's 7, 8, and 10. Right? Okay. But 9 could be there, but I don't know that. It's not. Okay, so just kidding. So, okay guys, here. Now we're talking about, so we understand the concept of TPM. Okay, can anyone tell me in your own words? Yeah. What is this diagram telling you about TPM? Anyone? Yes, ma'am?
This diagram is telling us that when you encrypt your data on your hard drive, it sets everything with decryption key for the TPM, and the TPM is located on.
So what's the benefit of that?
Benefit is someone takes the hard drive, but they can't take your decryption key. But isn't the back vault, if something happens to the TPM, you can't decrypt any of your data after that?
So you should have a backup somewhere else as well. So if somebody hacker took away the hard disk, you would have the key. Maybe you're away. You would have the key, or the motherboard has the key.
The motherboard.
Motherboard's chipset has the key. I asked you to have a witch hunt of the key, right? And the key was not there. I mean, like the BIOS. I was asking you to search for BIOS. You see a lot of chipsets, small chipsets. One of them is TPM. They don't actually write that TPM. One of the chipset is TPM chipset. And there are many small chipsets there. Maybe there are 60 or 70 chipsets there right now. It's very small as well. small chipsets. One of the chipsets' responsibility is for storing the encryption decryption key. So hacker can take the hard disk but cannot decrypt it to see the data. If your data is safe, it's okay whoever has the hard disk. I mean, it's not okay, but you're still safe, right? Because they cannot see the data. And data is all about, it's all about data, right? If a rival company gets the data of your company and the data says that, oh, the clients that your rival company has and this company is given prices to the client this one, so the rival company will know, oh, these are prices given, so I will give those same clients lower prices of the products, and your company in 6 months gone down, business down, layouts, and firing, and that's it. Disappeared, company bankrupt, that's it, just because the rival company got that data. So it's all about data, right? Okay, so we understand TPM as a security measure. And why were we talking about that? Because BIOS has that configuration for TPM as well. Really? BIOS has configuration for TPM? So we can configure TPM within BIOS. You want to enable TPM, go to BIOS and enable that. Or you can just go to your home, at least boot from BIOS. Oh, if I say that, please boot from BIOS and take a picture of your BIOS as an assignment, would you be able to do that? Now, how to boot from BIOS? Anyone knows how to go to the BIOS from your local computer? How?
Before you get to when you're restarting your computer,
Restart.
before you get to the Windows screen, you have to press, I think it's F.
Yes. So when you restart your computer, you have to press either the. So every laptop and desktop, it's different. The key that, so for some it's the del key, delete key on the keyboard. When you press del, it will just go to the BIOS when it is starting. Suppose you power on right now, at once start pressing del, it will go to the BIOS directly, right? And BIOS looks like, I already have that picture here. I was showing you how BIOS looks like. This is how it doesn't look like. Okay, no, it's not this. Power off, and then power on firmware. So BIOS looks like this, and it says here, so, and it says here Phoenix BIOS, right? So how do you go inside the BIOS in your laptop or desktop? You restart or shut down and power on, and then press the key, whichever key. So suppose I have Lenovo laptop. So I would go to the Lenovo website, or I will just Google it. How to go to BIOS in Lenovo W540 model. Which laptop is that? Which company?
Dell.
Dell. Sorry, Dell. Dell, and what's the model?
It's
ThinkPad. I have ThinkPad Lenovo. So
I think it's a Lumia. No, Latitude.
Latitude. Okay. So Dell. So I would just go Google Dell Latitude, how to go to BIOS. So they will say restart or shut down and power on the computer, and then press. For every vendor, the key is different. Sometimes it's the same. So F12, F12, F12. For some vendors, F10, F10, F10. For some it is F1 or escape or del, delete key. So it gets interesting from here. Well, for me, but I don't know about you, but well, because that's an assignment now. And you have, everyone has brought their cell phone, right? What kind of question is that? Obviously, you brought your cell phone. So everyone's cell phone has a camera, right? That's another ridiculous question. So, so assignment. No, this is not going to disrupt your home computer, right? If it were, I would not give you that assignment. But it's up to you. You want to learn, this is the way to learn, right? So on your home computer, restart it or power off and start. Then do what? Then press the key that takes you to your desktop / laptop's BIOS. right? So the task is you need to know which key for your particular computer, laptop or desktop will work to take you to the BIOS, right? Once in BIOS, take a picture from your cell phone. Just the BIOS screen, as I showed you, it's always blue or black, right? So just take the picture of the BIOS, or maybe you can take a selfie. So you're smiling like this, and in the background you're in the BIOS. Sweet each, or just take a picture of the BIOS from your cell phone, right? You need to tell me which key you discovered. So you need to tell me which laptop or desktop model it is, which is, suppose you have a desktop from some company and they did not mention that, otherwise it's normally branded desktops. So maybe you have HP, maybe you have Dell, maybe you have, and laptops you already know the brand, I mean it's of some company, right? So once in BIOS, take a picture from your cell phone. So put the picture in MS document, MS Word document, seriously, did I just come up with a new application here? MS Word document, put the picture there, right, from cell phone. So this means you need to know when you take a picture how to, so email it to yourself, open that email in computer and download that picture from there, right? So you have to do all that computer work, right? And then put it in MS Word document. In the Word doc, put your full name, obviously college name, and the laptop slash desktop model, and what is the key you pressed to go to BIOS for your particular laptop desktop, right? Laptop slash desktop. So just the BIOS picture, the detail of which computer, which company, and also that which key you had to press, because it's different. If I am pressing here, I think for this one, once I needed that to enable virtualization, and I had to Google it, that what is the key for Lenovo ThinkPad W540 model, and then they were saying it's Dell. Delete key, I had kept pressing, and you have to press again and again. Otherwise, easiest way, just YouTube it, how to go to the BIOS, and you will learn within 2 to 5 minutes the task will be done, right? But you have to do that, you have to gain that confidence, right? You can ignore that as well, but it's your loss. If you do that, it's your benefit, right? If we can do that for any device, this means the confidence level increases, right? This is what you have to do. You have to face wherever, if you're relating to, or you're being related to A+, then they would expect you to know how to go to BIOS. I'm not asking you to make any changes. That we will do here in virtual environment, where we will change the boot sequence. We're going to try to boot from some other device, but here, go to your actual machine's BIOS, take a picture, and this is it. So guys, can you take a picture of that?
BIOS is kind of like a command prompt for the inside of your computer.
It's a menu-based configuration setting for the whole computer hardware.
Like a taskbar for your computer hardware.
Exactly. So, and how many disks are there? Are they activated or not? How much RAM is available there? How much? What kind of security you want to put there? So, and virtualization you want to support. So, hardware-related settings that are very critical and sensitive, and we should not change anything unless we really know what we're doing, right? Other than that, otherwise we don't change anything, right? So, and the boot sequence, obviously, that's for the reason for. So guys, everyone took that picture of the assignment. So before the next class, which is Monday, A+ Monday now, not tomorrow, right? So before that, please, you have my email already, right? So email me the MS Word document with your name on the MS Word document as a document name, your name, and the assignment. This is assignment for BIOS. So assignment dash access the BIOS. So just type that. This information has to be there. The model of the computer, which key to use to access that, and were you able to successfully access your home machine's BIOS. Once you access that, just exit. Then just check the command. Either F10 is exit, save and exit, or just go to exit and go out. Don't make any changes. Well, I would recommend that go ahead and try to read or be familiar with some of the options there, but don't change anything. That's all, right? Okay, we got the details for the assignment. So this means before Monday, you're sending this to me, right? Cool. Because there are more tasks coming your way, and that will only increase your confidence on your hardware, and that is only your benefit if you do that assignment. So my recommendation is do not ignore any of the assignments that you're getting, right? So let's go ahead, and it's 1:31. Why are you staring at me now? Because I said 1:31.
You said let's go ahead.
Let's go ahead. Yeah. What does that mean?
Let's continue.
Let's continue. Exactly. Yes. Let's go ahead, and then 1:31. Then I was looking at everyone, and so it does it have some meaning? No, it has no meaning. That means let's continue. So here now, this is low jack. Seriously. So BIOS and then low jack. So what is this? For laptops, originally known as CompAPlus, is a proprietary laptop theft recovery, right? So low jack for laptops, if we go to Wikipedia here, so originally known as CompAPlus, is a proprietary laptop theft recovery software, laptop tracking software, with features including the abilities to remotely lock, delete files from, and locate the stolen laptop on map. Wow, really? So well, if you're there, you can just check that if this feature is there or not. It is there with all latest laptops, new laptops. Latest means in last 2-3 years, 4 years, 5 years. Is this feature of tracking the laptop, stolen laptop, is there. I don't know why it didn't power it on yet, but they have that feature available. So this is the feature for Solo Jack. We understand that it's gonna remotely, you can delete the data, because data is really important. So let's go ahead. Right? Okay. So here, front panel and top panel connectors: power button, power light, reset button, drive activity lights, audio jacks, USB ports. Now this could be very easy. I mean, nothing difficult here, right? What is it talking about? The front panel connections and back panel, or it's talking about the front, right, and top. Sometimes the button is on the top of the machine. Sometimes it is normally it's on the front of the machine, right? So power button, power light, reset button. Reset is restart. There's only one button now. It used to be 2 buttons there, one for power, one for just restart, but it is now just one button. So guys, if suppose your machine is working and all of a sudden it freezes, what do you do with that machine if somebody tells you to restart that machine or shut down that machine? Pull? Hold how long?
Until it shuts off.
Hey, you've done everything. What have you not tested in hardware? So suppose the machine is frozen and you cannot click anything. You hold the power button down for until it shuts down. Oh, you've done that too, right?
Sure, it's happening. It's happening.
Yeah, so you hold that button down for long until it shuts down, right? So, but that's one purpose. Other than that, power on, or just press once and it is working fine, it will power off as well. Or hold it down if it's frozen and it will shut down. So other than that, yeah, nothing much here, right? Motherboard front panel header. Seriously? So front panel header is actually behind that front panel here. So well, that is something that we may not be able to see, but the front panel lights here. So if you want the USB to be connected, audio to be connected, and power button to be working, so there's a small panel right behind this here, and that panel is connected to the motherboard, and because of that you're able to use this panel. So there's always a small set of chips there that is working right behind this front panel here, right? So obviously that would be the motherboard that they're talking about. Oh, well, not motherboard, the header they're saying, but it's a set of chips there. So CPUs, there is a dual inline package, there is PGA pin grade array, so there's DIP, it's not RIP, it's DIP, and there's that PGA pin grade array. Now these are the technologies, and then there's LGA. So we're going to be talking about in detail. Now these are there. This slide is giving away a lot of terminologies that we still need to go in depth with. So in next slides, of course, I'm going to bore you some more. It's going to be very interesting for you to know all the in-depth functionalities of the motherboard, but sometimes the theory gets really overwhelming, and it's like, seriously, what is he talking about, really? So I just want to make it as interesting as possible, or as understanding as possible, but when it comes down in depth, then it gets tough. So then you just, it's your own interest that you try to keep, there, or there's a cell phone chat that's going on also. You can attend to that while I'm doing that kind of boring theory. Please don't do that. Okay. So, but anyway, there's that DIP, PGA, and LGA, and then, well, they say that instead of explaining the whole thing, we went in this slide for another CPU socket. Now, this is still talking about the CPU socket here. We talked about that before as well. So I'm just going to go ahead a little, and they talk about the CPU features there. So again, there is another slide where we're going to be talking about how it is, but you can see from the design here, dual inline package. So this is this design here, and pin grade array. You see a lot of pins here, which is, we already saw the processor with pins. So that is called PGA. So the processor that I showed you was PGA, right? And there used to be CPUs. These guys were also used to be called CPUs, but that's old now. And in fact, this is also old now. Now it is without pins, right? So, but this is pin grade array, which was that processor. So that's what they're trying. This LGA is, they don't have a picture for that, but this is even older. So CPU socket, this we know already. I was thinking of creating a question here, but I think what I will be asking you already know that. Okay, some more challenging one I'll pick up later. So CPU features here, hyperthreading. Quickly in one line, what is hyperthreading? Yes, sir.
Creating more processes.
So that would be coming after one more thing is done. Or so if you can elaborate a little, how are you able to create more processors? When does hyperthreading kicks in? When?
So that comes before.
Before
You're saying before that.
before there was another terminology there. Remember? No?
When you have the quad core and you divide it by more.
Okay. So one processor, quad core. So within processor, if you want to further divide it in a quad core processor, you divide it in 4 sections. So what do you call those 4? You call them cores. Within core, you further divide a core with hyperthreading, right? So you further divide one processor into cores, but you further divide cores into multiple processors with the help of hyperthreading, right? So one socket, 4 cores, and further divide 4 cores into, with the help of hyperthreading, it becomes even multiple processors. Each core becomes 2 processors, right? So hyperthreading, multi-core already. Multi-core would be multiple cores, dual core or quad core, right? Hyper-threading just further divides those cores into more independent processors, and they actually show in Windows as well. When in Windows implement hyper-threading right away. So if this is a quad-core, well, I said that.
So first multi-core and then hyper-threading.
So hyper-threading is by topic, they have put that there. Otherwise, first it is always a core. Now it's not like that. First core activates, then hyper-threading. As soon as you start Windows, they both are activated. So it's a quad-core machine. This one. So already Windows knows that, oh, it's a quad-core. Okay, let me use 4 cores, and hyper-threading is also enabled here. So let me use hyper. So as soon as you start, it's 8 cores available. It's using 8 cores already because it's built in.
How do you enable?
No, it's by default. You don't have to manually do anything. You just install Windows there, and operating system has to be smart. So Microsoft operating system knows that what kind of hardware is around. If it's a dual core, detect that there's just 2 cores here, and hyper-threading would make it just 4 processors. If it's quad core, it's just 4 cores there, and hyper-threading will make it 8 cores, right? So operating systems are smart enough. Yes, they will detect that right away. But what I was about to show you, Task Manager, performance. There you go. Do you see some familiar information here? Ta-da. Can you notice what have we talked about? What information we have talked about already? This is my machine's cores and cache and socket. Everything is showing here. We talked about all that. So what is it? Everything familiar? I have in my laptop 1 socket. I have 4 cores. This is a quad core processor laptop, right? W540. W series in Lenovo is for heavy use. If it's T series, it's not that heavy. It's dual core maximum it will go. But anything W in Lenovo, ThinkPad, would be heavy use. So my recommendation is, if you want to stay in the field of IT, you want to test some, you want to really go technical, have a good hardware first, right? So I also took it in first hardware. I took it in installments. The second one, it was refurbished, so it's working forever. It's good. So cores for logical processors. Now logical processors, I'm not talking hyper-threading, but it's the same thing now. Hyper-threading made these extra processors, which in Windows you will see that as logical processors. You know, I'm so tempted to give assignment number 2 now. That you can go to Task Manager and check what is your laptop or desktop, this information. Check this information. This is in Windows 10. I'm seeing in my laptop right now. So I can just show you how I went there. Anyone knows how I went there? So if I close that, how did I go to that information? Okay, Alt Control Delete and
Well, that's how you get the task.
yes, Task Manager. Then there you go. You're there. Where actually? Now where? Here where?
Performance.
Performance, exactly. So you need to, that's assignment number 2 now, and we're so excited now, right? Oh yes, I got assignment number 2. Okay, so assignment number 1 is also already piece of cake for you. Just go to BIOS. Come on, Teach, give me some challenge. I know you're saying that. Or hey, Teach, please, no third assignment, please. But you know, it really makes your knowledge stronger when you see in your own computer that same information. So on your computer, you just need to take a picture of that information for your laptop or desktop now, right? And put it as second document, second assignment, right? So on your computer, go to Task Manager. Everyone knows how to open Task Manager? Task Manager. Everyone knows? Go to Control Alt Delete, click Task Manager, go to Performance. So on your computer, go to Task Manager, and then click Performance tab. Performance tab, and take a picture of your CPU related information.
My one is 2 cores and 4 logical processors.
Ah, you're there. That's good. And do you have L1, L2, L3 cache?
Yeah.
Ah, good. So 2 cores, 4 logical processors. Good. Dual core. Very good. Very good. So, hey, you've done the assignment already. That's not fair. You're supposed. No, that's good. To take a picture of your CPU related information. Information needed is how many sockets, how many cores, how many logical processors, and now we know a logical processor means with the help of hybrid threading there are further processing there. Okay, and then how many L cache. Normally it's always 3, L1, L2, L3, but some computers may not have it, so this means that is slow. You know, that computer would be slower than others. It's not like slow, really slower. So how many L cache? It's normally it is L1, L2, L3 there or not. One picture is your answer. That's it. Take a picture, put it in the guys, also take a picture of this. So that's a separate document, right? That's a separate document, assignment document. You have to email me to on. Actually, you know, you can just email me at. Yeah, you could have emailed me on my college email as well. Say that net+college.ca or IT guy. No, that's a third picture. Sorry. So my college email is this, and my Gmail is this, right? So, but take a picture of this one. Sorry, the third one. So, but that's a complete one, final one, right? So, you just have to tell the model of the machine. You can just take a picture of that too. But one is BIOS. If you're inside the BIOS, you're good. Then power on the machine, go to task manager, go to performance, and then you will know, oh, I have a dual core, oh, I have a quad core already, okay, i5, i3, i7. So i5 normally is dual core, i3 is single core, i7 is quad core.
What about i9?
i9 would be then more cores. It would be supporting actually 64 GB if there is i9.
I've seen an i9 chip before. I think it was in a gaming laptop.
Oh, okay. Normally it's Alienware, that is the top laptop. Ah, you have Alienware.
Well, my brother built his computer, so he has the water cooling and all that kind of stuff in it. And I think
Alienware. Okay.
He's a gamer. He's a hardcore gamer.
Oh, and hardcore. Okay, his laptop. This assignment. And yeah, don't let him freak out. So, yeah. Whoa, what are you doing? Well, yeah.
Water cooling will make it. What is the difference between water cooling and the just conventional heat sinks?
Water cooling will make it. It just means water cooling. If it is required, just means the heat would be huge. So it is going to heat up a lot. They're expecting that this processor, it's for gaming. So big graphics are being loaded and more detail is loaded within seconds. So it will really heat up faster. If you just put a heatsink on that kind of processor, it will heat up and it will freeze, it will shut down. So if it needs more, then definitely water cooling will make it cooler on the level that it needs, right?
So water cooling will make it very cool. It wouldn't overheat.
Keep it cool because it needs that kind of cooling. That's why you would be putting water cooling in the first place. Otherwise, you'd be putting some very good quality fans there, or 2 or 3 fans actually, just for one processor, or a big heat sink and one big fan on top of that. So if it needs water cooling, wow, it better be performing good. So guys, we got that picture. So we're sending those assignment before Monday, right? And then tomorrow is Network Plus. So that has to be actually taken in the class because I need you to log into computers there. So we were talking about this multi-core throttling. Throttling means, hey, somebody's packing up. Collective feelings were hurt now. So throttling overall means that the processor can do that work to a certain level, right? There is always a limit for a hardware. Every hardware there's a limit, right? So throttling is that one program is making processor work so much that processor will say, hey, your whatever your limit was has reached, and I'm not doing more work that is coming from your side, Mr. MS Word or Excel or whichever process is sending a lot of requests. Throttling means that, okay, per process I am taking this much request. After that I'm going to reject you, or I'm going to queue you up, right? So throttling just means that for each application, for each process, that it will give enough power for that for a certain time, or certain level of power it will give, certain level number of requests it will receive. After that it will queue you up. So that is called throttling. This for applications as well as for processors. Is the concept in IT for throttling is that each application has enough number of there's a limit to sending requests by each application. After that it's queued and then again responded. So that only happens when you have with quad core 8 processors. Maybe throttling never reaches there, it's just done, right? If it's dual core, maybe it's 8 core, but there are so many applications open that it's too much requests. Even i7 quad core would have a limit, right? Some limit. So when it reaches that, throttling just means that, whoa, no more. Now queue up, I'll attend to you later, right? And 32-bit, 64-bit processor. 32-bit is really old. 64-bit is nowadays it's all 64-bit. So forget about 32-bit processors. They were slower. Applications were slower as well. 64-bit is much faster processing there. And virtualization support. This we will be testing. In fact, in tomorrow class we're going to be having virtual environment. We need to create 2 machines because we need to test networking right away, right? So, and integrated GPU. Ever heard of GPU before? GPU. So gamers know that, or cryptocurrency people know that. So GPU is graphics processing unit. So CPU is central processing unit. So graphics, obviously the word graphics should say it its task or its purpose. So GPU is for if you have Photoshop, if you have AutoCAD applications, if you have cryptocurrency, if you have live streaming a lot going on, whatever needs graphics loaded in high details, high definition. So GPU is used there. So GPU would be on used for these display adapters. It will be not on that. GPU is the performance of a CPU, but it is specific. CPU is giving specific performance for graphics loading. CPU is handling that. Already the display card would have 4 GB RAM, 2 GB RAM, 6 GB RAM, but it will ask, hey processor, are you supporting GPU as well? Because I really need some more power to load my graphics. So that's where GPU or graphical processing unit comes, right? Okay, so let's go ahead. What does that go ahead mean? So the next very long task till 3:30 would be, till 3:30 we're going to be doing the next assignment now, right? And that would so 2 o'clock, 3 o'clock, 3:30, right? So since you are all free after 2 as well, so what? Oh, you know that I'm playing with you. Okay. Anyway, so let's see you tomorrow with Network Plus introduction. And oh, you want to continue? Okay. So integrated graphic. So let's go ahead and see you tomorrow. Any questions? Let me know. And the 2 videos are there now.